So in physics, whenever you will study college, school, any class, the very first thing you will learn in physics is vectors, units, dimensions, because you are going to deal with them in every chapter. Before I begin to teach you that and start getting you into the grind of the subject, few general guidelines I want to give. We are in the habit of making notes, whatever the teacher is saying, extra sincerity, religiousness. I used to have that. I shouldn't miss a single word of it. Unfortunately, at that time, there was no technology, there was no recording of the lecture, and there was no that good study material. So you don't have to get into that mode of copying, noting. Your mode has to be understanding the logic, what I'm saying. And then when I give you a question to solve, then you have to be fastest finger first. It'll be like a war in my class. पहले कौन करेगा वो खेलेंगे क्वेश्चंस को आंसर कौन करेगा that shows me who's interested, who's understanding, who's participating. That is what I want. Are you getting it? So if there is some concept which you feel is interesting, you can note that down briefly. If there is something I'm insisting, that you should note down. That's it. बहुत ज्यादा नोट मेकिंग में टाइम नहीं इन्वेस्ट करना है. अंडरस्टैंडिंग, लिसनिंग प्रॉपर्ली एंड पार्टिसिपेटिंग. वी हैव टू अंडरस्टैंड इट हियर. घर जाके नहीं समझेंगे. नोट्स बना लिए और घर जाके पढ़ लेंगे, वो केस नहीं करना है. इज दैट क्लियर? यू अंडरस्टूड दिस? सेकंड, initially while studying books, sometimes the story will be too lengthy. कहीं पे कुछ एक्सप्लेन कर रहा है, कुछ बोरिंग लगेगा, कुछ ऐसे. क्रक्स क्या है? पूरी फिजिक्स में हार्डली 50 to 70 कॉन्सेप्ट्स मैक्स. और वो कॉन्सेप्ट्स इफ यू अंडरस्टैंड, हम क्या करते हैं, हम एक टॉपिक पे लगते हैं और उसी में एक महीना मेहनत करते रहेंगे, उसकी एक एक छोटी छोटी चीज को स्टडी करते रहेंगे, और बाद में रियलाइज होगा कि यार उतना आउटपुट इससे कुछ ज्यादा पूछा भी नहीं गया. और ये तो नहीं केस बाद में हमें समझ में ही आ जाता एवरीडे. सो एक्स्ट्रा रिलीजियस ना होके कॉन्सेप्चुअल क्लैरिटी पे फोकस रखेंगे एंड थोड़ा कॉन्फिडेंट भी रहेंगे. और थर्ड इज फर्स्ट 1 month प्लीज गिव योर बेस्ट. फर्स्ट 1 month वो बहुत इंपॉर्टेंट है. इनिशियली अगर कॉन्फिडेंस लो चला गया, समझ में आना नहीं शुरू हुआ और आपने घर जाके मेहनत नहीं की, तो गाड़ी डिरेल हो जाएगी. और अगर आपने फर्स्ट 1 month सिंसियरिटी दिखाई और एक्स्ट्रा हार्डवर्क रखा, उसके बाद आपको पेस, प्रवीण त्यागी, किसी टीचर की भी जरूरत नहीं होगी. यू विल डेवलप दैट आर्ट, कॉन्फिडेंस एंड क्लैरिटी कि आई कैन डू इट. 1 or 2 months इतने क्रूशियल है. सो जस्ट फर्स्ट 1-2 months एक्स्ट्रा हार्डवर्क. रेडी? नाउ I don't know why they have kept these markers. They're not needed at all on the electronic board. Surprising. They're used to old system. Anyways, now coming to coming to the coming to vectors. What is a vector? What is a vector? A quantity which has
magnitude and direction.
Magnitude, direction. Okay. Current has magnitude.
Yes.
Current has direction.
Yes.
Is it a vector?
No.
It is not a vector. So your definition is not complete.
It is something that also follows the vector law addition.
A quantity. What is a physical quantity? First, tell me that.
A quantity that can be measured.
A quantity that can be measured using instruments in a laboratory. I love you. Can you measure how much I love him? 5 kg, 100 meter, how much I love him? What is the unit? Can I measure that? I'm very sad. How sad? 5 kg sad. नहीं कर सकते ना. So things you can't, emotions you can't measure. What are physical quantities? Physical quantities are quantities which you can measure. Now, for those physical quantities to, अच्छा वो तो अभी बाद में आएंगे. Vector current has magnitude, direction, and your definition says it should be a vector. So your definition needs some correction. That correction is the third point. It must follow vector algebra. Please come. That physical quantity must follow vector algebra. What is vector algebra? You learned 2 plus 3 is 5, 2 into 3 is 6, right? That's normal algebra. In vectors, how vectors will be added, subtracted, multiplied, divided? आप आगे आइए. आपकी हाइट भी कम है और बैठ जाओ पीछे. आ लिया समझ में? यहाँ पे आइए, यहाँ पे आइए, या यहाँ पे आइए. आइए आइए. बस आप यहाँ जाइए, यहाँ जाइए. क्विक. ऑल ऑफ यू मस्ट बी 7:30 के बाद मैं बंद कर दूंगा. ये आज फर्स्ट डे है. यू डू नॉट नो. आई लर्न दीज लेसन्स फ्रॉम माय आईआईटी प्रॉफ्स. क्लास में एंटर टीचर एग्जैक्ट पंक्चुअल. आई हैव टू बी पंक्चुअल इन दैट केस. और फिर लॉक्ड. 1-2 दिन बच्चे बाहर खड़े होते हैं, तो उसके बाद से बच्चे टाइम से पहले. सो प्लीज एंश्योर दैट यू डोंट मिस आउट इवन अ सिंगल थिंग, अदरवाइज पूरा लेक्चर आपको बाउंसर चला जाएगा. ठीक है, रेडी नाउ. So magnitude direction must follow vector algebra. Vector algebra is that set of rules which decide which vectors follow for addition, subtraction, multiplication, division. We will study that, and that is called vector. Okay? And this is the proper definition of a vector. Are you clear? Let me see some basic definitions. What is displacement of a body?
The shortest distance.
The shortest distance. ए पॉइंट है, बी पॉइंट है, ये इनिशियल पॉइंट है, यहाँ पे फाइनली पहुंच गई. तो दिस शॉर्टेस्ट डिस्टेंस इज कॉल्ड डिस्प्लेसमेंट. रॉन्ग डेफिनेशन. गलत रट्टे लगा के आए हैं आप. 1 मिनट में आ रहा हूं मैं. ये गलत रट्टे लगाए हैं. देखो अब सीखो. कोई करेक्ट कर सकता है इसको? डिस्प्लेसमेंट ऑफ अ बॉडी, इनिशियल पोजीशन इज एट ए, फाइनल इज एट बी. गड़बड़ कहाँ होती है? इफ यू डोंट नो द बेसिक डेफिनेशन, इफ यू डोंट नो द मेन पॉइंट, you are stuck, you will make mistakes, and that is what is the missing link. And once you get that clarity, after that you find things very easy. Now tell me, anyone wants to correct this?
There's no direction.
Yes. When you say it is the distance between the initial position and the final position, where are you talking about direction? And you know displacement is a vector, so what is the direction?
From initial point to final point.
So if I just tell you the definition of displacement, correct, just note it down. The vector, सुनिएगा पहले समझ लीजिए. The vector joining the initial position to the final position, that vector is called displacement. Initial position of a body is this, final position is this, and this vector joining the initial position to the final position. So you have specified direction also, and this is defined as displacement of a body. This is the initial position. This is the final position, and this is a powerful statement. So displacement of a body, displacement is a vector. We should talk about its magnitude and direction both whenever you talk about any vector. And the vector joining the vector join joining the initial position to the final position is called displacement vector, displacement of that body. Now, the power of this correct definition, I'll make you realize today in the lecture. Why it was important to know it this way. Now, next. Very basic things. Now, If suppose, so vector. So vector is represented like this, any vector. If A is a vector, always an arrow over its head. Sometimes they will tell you can make it bold. अब वो bold ज़्यादा dark करना वो debatable चीज है. So safest thing is draw a direction and say this is a vector quantity. This quantity has some magnitude and it has some direction, and that's why we are representing the direction with a sense of direction with an arrow over it. So this is very clear. Whether you make it this or you make it this, it's all a vector. The moment you mention arrow. So vector representation. Now, so this is how we represent a vector. A vector has magnitude. So this vector has magnitude, and that magnitude is, say, this vector has some magnitude. That magnitude is represented like this. This is the symbol. And it has some direction. The direction should be in the direction of a vector. So if I say I multiplied by a unit vector along A, so this is a unit vector along A. So this is the magnitude and this is the direction of A vector. These are the symbols. So A vector can be written like this. Just introducing you to the representation, the way we write a vector. That's it. Don't worry. I mean, very soon you'll get familiar with all this terminology and you will start getting.
Sir, magnitude into direction.
Magnitude into direction. This is the magnitude and this is the direction of that vector. A unit vector, this is a unit vector in the direction of A. Unit vector in the direction, whichever is the direction of A. And this is magnitude of A vector. And magnitude is represented by this symbol. So this is how we write a vector. Next. There are certain properties that we need to know for a vector. If this is a vector A, and I draw this vector in space like this is a vector A. This point is called the tail of a vector. This point is called the head of a vector. The length of the vector is proportional to its magnitude. So this length will be length is proportional to the magnitude of the vector. Now, what do we mean by this? If I say this length is 100 Newton force. So what will be a 50 Newton force? In the same direction? Half of it. So if I go to the midpoint, this force will be a 50 Newton force in the same direction. And I can draw this force separately. This is a 50 Newton force. Sorry, I don't know how to play with this digitally. Now, so if I want to draw a 50 Newton force, same direction, half the length, that will be 50 Newton. If I want to draw a 200 Newton force in the same direction, double the length. So the magnitude can be changed and length is proportional to the magnitude. All of you are getting this. Good. Now, if I say this is vector A, what will be this vector? Sometimes they write it. Very unusual, but sometimes they mention it. This is A in opposite direction. Or I can also say minus A. So what is minus sign meaning? In numbers, it had some other meaning. But in vectors, what is minus sign? Opposite direction. So the same vector, this was vector A. So what is minus A? Same vector in opposite direction. This is minus. Correct. Then there are certain things like parallel vectors. This vector is parallel to this vector. Yes or no? So they are parallel vectors. Collinear vectors along the same line. Coplanar vectors in the same plane. So all these vectors that I'm drawing, they are in the plane of the board. None of them is coming out of the board, has any component out of the board. So such vectors are called coplanar. Coplanar means same plane. Collinear matlab along the same line. Coincident, same point. Good. Co-students, same batch students. Something like that. Now, basic. Oh, the booklet is there, step app is there. All of you should get access to it. All these small definitions are there. Okay, so let's go to the interesting part now. So there are 4 things you will learn in this chapter: addition, subtraction, multiplication, division. So I have 2 good news, 2 bad news. Should I deliver the bad news first?
Bad news first.
Good news first.
Bad
news. Okay. So bad news is vectors are going to be everywhere in physics. Electricity, electric field, magnetic field, velocity, acceleration, anywhere, projectile motion, circular motion, everywhere you'll study vector. So it's a dead serious, dead important, very important topic. बस उतनी बैड न्यूज है. गुड न्यूज ये है कि वेक्टर्स में हम 4 चीज पढ़ने वाले हैं. वो बैड न्यूज है. और गुड न्यूज ये है कि उन 4 में से 2 चीजें डिवीजन तो पॉसिबल ही नहीं होती है. A vector cannot be divided by another vector. So एक टॉपिक तो उड़ गया. अब 3 बच गए. 3 में अगर A एडिशन हमने सीख लिया, A प्लस B को ऐड करना सीख लिया, तो सब्ट्रैक्शन अपने आप आ जाएगा. कैसे? A प्लस माइनस B will be A minus B. Do you understand what I'm saying here? ये मैंने क्या बोला? What have I said just now? If you have to find A minus B, what you have to do is create a vector which is minus B. This will be a vector which is opposite in direction to B. And then add these 2 vectors, A plus minus B. You will get A minus B. So division, subtraction is also done if you have understood the addition part. Got it? So 2 topics gone. Now we are left with 2 topics: addition and multiplication. Okay. In addition, again, there are 2 methods. One is triangle method, you have learned. Second is parallelogram method, right? Have you heard of these 2? It's there in your 8th, 9th, and 10th, all 3 classes. First chapter, vectors. And you do not know. How many of you don't know what is triangle method? Oh my goodness. How come? There was no vectors in your 8th, 9th. Oh my God. Oh, then we need to do it properly. Okay. Good, you told me that. अच्छा ये हमारे FB में कराते हैं. ठीक है. All of you please pay attention. So there are 2 ways to add 2 vectors. For example, suppose I tell you I am walking towards, this is east, this is west, north, south. Generally south is towards you. This is the convention how to write the directions. Now, suppose I tell you I am going for a morning walk and I am going to walk 20 meters towards east. Now, then I decided after reaching here, I will walk 20 meters towards north. Now, tell me what was my initial position? What is my initial position? Here, I started from here. What is my final position?
Head of.
Now, can you tell me? And this was my first displacement. This was my first displacement, right? I moved 20 meters towards east. So I'm writing good communication. आप सुनिए आप वहीं बैठे रहिए आ जाइए कोई भी आ जाए मैं इतना रिपल्सिव फोर्स नहीं लगाऊंगा कि आप रिपेल होकर दूर दूर बैठे नेक्स्ट टाइम से ये जो फर्स्ट बेंच है ये मैंने रिजर्व कर रखी है ये डिजर्विंग लोगों को मिलेगी इसलिए मैं इसको खाली रखता हूँ हर चीज प्लान के हिसाब से चल रही है ये भी जानबूझ के गिराया मैंने ट्रस्ट मी कुछ भी यूनिवर्स में ऐसे नहीं है जो मेरे प्लान के हिसाब से नहीं हो रहा देखते रहिए नाउ अब आइए सो फर्स्ट डिस्प्लेसमेंट इज 20 meters towards east. I have to specify direction. Words में, vector form में, whatever way. And second displacement is 20 meters towards north. Bracket में. Now, can you tell me what is my total displacement? I have told you
400.
the vector joining the which position to which position, बताइए. So initial position, final position where I reached, and this vector will represent my net displacement, resultant displacement. So a resultant vector or resultant displacement will be first displacement plus second displacement. All of you understand this?
Yes, sir.
Did I actually went through this path or I went here and then I went here? I never traveled this path. I never traveled that path. But the displacement is shown as this. What is the distance covered by me? 40 meters. What is the displacement coming out to be right now? Pythagoras theorem. You know this is 90 degrees. So we can apply Pythagoras theorem for a triangle. You all know this. And this will be like 20 root 2 meters. And you can also tell me what is this theta? How much? It will be 10 theta will be this side upon this side, and 10 theta is 20 by 20, which is 1, which is theta is equal to 45 degrees. So you know how to find the resultant to a great extent already. Am I right?
Yes, sir.
Now I will give it a formal definition and a structure that how do you add two vectors? So if you have a vector 1, you have another vector 2, and you want to add them, just keep the head of tail of one on the head of the other. Tail of one vector on the head of the other vector, and you will end up getting the resultant. You have to get the direction from initial position to the final position. Initial point to the final point. Is that clear? Now, what if I do S2 plus S1? Suppose I decide to do it the other way around. First, I walked 20 meters towards north. So I have a vector in this direction, 20 meters towards north. Then I decided to walk 20 meters towards east. ये decide किया मैंने. Now what is my initial position and final position? Quick.
Same.
This is my initial position and this is my final position. Will I get the same vector?
Yeah.
Same resultant? Yes. I am starting from the same point. I am reaching the same point, and this is going to be my resultant vector R. Will this be S2 plus S1 or not?
Yeah.
And this will be same in length, same in direction. So you will realize I'm still getting the same answer. So vector addition is commutative.
Oh.
S2 plus S1 is same as S1 plus S2. Yeah,
Can I just switch off my phone?
sure. All of you should keep your phone switched off. Or on silent at least. Now, So are you getting this? Okay. This is called triangle method. So now giving it a proper definition and making you understand in general, if I have a vector A, I have another vector B, and I want to add these two vectors. How do I add these two vectors? Please tell me first.
Put the
Will A plus B will be same as B plus A? Yes. What are you going to do? First, tell me. If I decide I'll keep this vector here only, if I move this vector, shift this vector from here to here or anywhere, will it remain the same vector?
Yeah.
For a vector, two things are important. Its magnitude and its sense of direction. If the direction remains the same, if its length remains the same, we are dealing with the same vector. Now, if I make this vector, shift this vector from here to here and keep the tail of this vector on the head of this vector. Now, what will be the resultant? Quick. I have to start from here, reach here. This third side of the triangle will give me the resultant vector, and that will be A plus B, and this method is called triangle method. Please understand this. Triangle method of addition. Everyone understood it? Second approach is parallelogram method of addition. So let us see what is that, and is there something new or different about it? Let's see that. If I have the same two vectors and I want these two vectors to be added through another method, which is called parallelogram method. In that, you bring the tails of the two vectors together. That is how they define it. So I am shifting this vector B and I am going to bring this vector to both the tails together. So I am going to draw B here parallel to itself, and this is vector B. The same length I have to maintain. I could have shifted that vector. I can give it a try. I don't know how it works. Okay. We have vector A, we have vector B here, and I will now shift vector B and in such a way that I place their tails together. This time I will take vector B and shift it here and bring their tails together. Now complete the parallelogram. Draw a line parallel to it. Draw a line parallel to it. Complete this parallelogram. This diagonal will represent A plus B resultant. This is called parallelogram method. R is equal to A plus B.
So the other one will be A minus B.
We'll come to that. Right now, just understand the two methods, triangle method and parallelogram method. In triangle method, you place the tail of one on the head of other. In parallelogram method, you place the tails together. And they are one and the same thing. There is no difference. Reason, just see this. If in a parallelogram, each side is parallel and equal, you know all this? So if this side is parallel and equal, will this vector be same as B vector? Yes or no?
Yes.
If this is B, this is also B. Now, am I saying the same thing or not?
Yeah.
Head of B, tail of B is kept on the head of A. This vector plus this vector is giving me resultant. This method you are saying triangle method. You were forming a triangle. In this case where I have shifted it here parallel to itself, keeping the length same, it's a parallelogram. Obviously, this vector is also B vector. And you are telling me we will place the tails together and we'll say this diagonal gives us A plus B. So triangle method and parallelogram method both are essentially giving us the same result. They are same almost. Now, what is the difference? When should we use which method? is one method more preferable over another method? Is there any advantage? जानने के लिए पढ़िए diamond comics, diamond comics. They used to do this with me. चाचा चौधरी, राका, साबू, कंप्यूटर, 4 लोग हुआ करते थे. और रेडियो पे एक ऐड आएगा कि साबू को किडनैप कर लिया, ये कर लिया, चाचा चौधरी उसे बचा पाएंगे या नहीं. ये जानने के लिए पढ़िए डायमंड को. और मैं भाई कॉमिक्स के चक्कर में घूमता रहता था. ऐसे नहीं करना चाहिए. पैसे नहीं होते थे, इतने मुश्किल से पैसे. रेडियो पे सुना देते पूरी कहानी. नाउ आई विल नॉट डू दैट. मैं आप लोगों को पूरी कहानी बताऊंगा. हाँ. नाउ so we understood the triangle method also, we understood the parallelogram method also. We realized both are essentially same. They give us the same result, and it is just two different ways of saying the same thing. But when do we use which one? So if you are ever given, say there is a displacement S1, there is another displacement S2, a man goes from here to here, A to B, B to C, so you already have the tail of one kept on the head of another. So you don't need to use parallelogram here. Which method will you use? Triangle method. And you will say, oh, this is the resultant. इसमें क्या दिमाग लगा रहे हो आप मेरे से? This is the resultant. And I used which method? Triangle method. And if he says there is a body on it, there are two forces. One force is 100 Newton in this direction. There is another force 200 Newton in this direction. And I want to find the resultant force. Which method will you use here? Why should you focus on doing triangle method here? No need, na? Their tails are already kept together. Simple. So we will say we will complete this triangle. So बस इतनी priority देनी है. Have you understood what I'm saying? So case to case basis पे depending on how the forces, vectors are placed, you will give that priority to that method and immediately solve it. Is that clear?
Yes.
Now, तो ये theoretically अब समझा दिया. अभी आएंगे numerical part पे. You will find everything very easy, and we need to master all this, understand all this, because every quantity you will deal in physics, 90% of them are going to be vector quantities. And children who are weak in vectors, they will keep getting stuck, finding difficult, mastering vectors, adding, subtracting, multiplying, dot product, cross product, bus. These 4 things, and we'll finish all the 4 today, so that we can get into the world of physics and tak दौड़ा देंगे काम. ठीक है? So when you go home, first thing you have to do is understand with full clarity, picture, and do some questions, and khatam. This weakness is gone forever. I'll make you enough practice today itself. Now, ready? So we understood these 2 methods. Now, this is going to be important. What do we mean by angle between 2 vectors? So I have one vector, this. I have another vector, which is this. These are the 2 vectors. This is vector A. ये आपको note भी कर लेना है. B. What is the meaning of angle between the 2 vectors? If I say this angle is theta or 120 degrees, is the angle between these 2 vectors 120 degrees? No. What do we mean by angle between 2 vectors? Please understand. Simplifying the definition, put the tails of both the vectors together. Bring the tails of both the vectors together. How will you bring the tails together? Keeping their direction intact and length intact. You can't change. The moment you change the direction or you change the length, you have changed the vector. But if you have kept the direction and magnitude same, vector remains the same. You can shift it anywhere across the globe. Now, so what I'll do is I'll bring, I'll bring this vector from here and shift its, bring its tail here. Now, be attentive. This is a gap that is left, and this is an imaginary line I'm drawing. This was 120. How much is this angle? 60 degrees. Now, if I bring their tails together, how much is this angle going to be? How much is this angle going to be?
300.
Now tell me, I have placed their tails together. Now the smaller angle formed between two vectors is defined as the angle between the two vectors. Just note it down. So what you have to do is, if there are two vectors A and B, put their tails together, and the smaller angle between the two vectors is defined as the, when they mention angle between two vectors is this, it is clearly understood the smaller angle when their tails are placed together is said to be the angle between two vectors. Please understand this.
What's the reflex angle for?
This angle.
Yes.
We do not, this is also the angle between these two vectors, but the convention, when I say the angle between two vectors is 60 degree, I mean this. Is that clear?
Thanks.
So this is the convention. When I am saying angle between two vectors is theta, you will place the tails together. The smaller angle will be theta. This is understood. So if I have a vector A, I have a vector B, I will place their tails together, and the smaller angle theta will be called angle between the two vectors. Have you understood it forever? No confusion ever. This is what they mean by angle between the two vectors. Clear? ये भी angle है. I'm not saying ये angle नहीं है, but the convention is this is what they refer to when they say angle between two vectors is 60 degrees. This is the angle they mean. They will never mean you to be using this angle as angle between two vectors. Are you clear? The smaller angle. Got it?
Yes.
Now, this was important. Now things will be interesting and easy, and we will be able to deal with vectors numerically and chalte hain. So one thing I want to tell you, tell me one thing. If I can add two vectors and get back one vector after adding them, can I break a vector
Yes.
into two vectors? I can. For example, I have a 100 meter displacement in towards east. Can I break it into two vectors saying that I have 40 meter displacement towards east and then 60 meter displacement towards east, and on adding them I'll get 100 meter displacement towards east? Am I right? So I broke this vector into two vectors. On adding these two vectors, I'm getting back this vector. And when I write vectors, I should write them with proper direction. Right now I'm being lazy, not writing the direction, not the symbol. I'm just trying to explain you the funda. But when you will write anything, you will be clear in your head. You have to mention direction and magnitude both. Never ever without specifying the direction when you're mentioning vector. Now, can I break it into two vectors like this also? One vector is this is the other vector. Can I do that? Yes?
Yes.
This vector plus this vector will give me the third side of the triangle.
Sure.
Can I break it like this?
Yes.
These two vectors on addition will give me this vector. Can I break it like this? These two, infinite ways I can break a vector into two vectors. On adding those two vectors, I'll get back the same vector. Clear? This is called resolution of a vector. Resolution means breaking of a vector. Now, this was normal resolution. Now, if I tell you, I want to resolve a vector into two vectors, but those two vectors must be mutually perpendicular. This is a vector A, and I want to break it into two vectors. But those two components must be mutually perpendicular to each other. Now, will there be infinite ways or will there be one way?
You can just create a circle.
Still there will be infinite ways. Still there will be infinite ways. See this. If I decide I will want one component in this direction, so the other mutually perpendicular component will be this. And this vector plus this vector. Just keep trying to understand the logic. No need to write, make notes. Just understand the logic. So can I say this vector C plus D will be same as A? Yes or no? And now I'll show you another mechanism to get two mutually perpendicular directions. If I say this is one direction and I drop a perpendicular on this, now I can say this vector plus this vector, which is E plus F, will also give me this plus this will also give me A. So I can break a vector into two mutually perpendicular components, two mutually perpendicular directions in how many ways? In finite ways. Now comes the third case. If I tell you I want to break a vector, I want to break a vector into two mutually perpendicular directions where one direction is clearly specified. Now how many ways? Now only one way. This is a vector A, and I am going to specify one direction. Okay, one direction has to be this. Now in how many ways I can break this vector into two mutually perpendicular components? One, unique. And I drop a perpendicular. And this direction is specified. It is making an angle theta with the vector. I want its component, one component to be along this direction. And then the other component will automatically come, the other perpendicular component. And why we need this case, I'll come to that. Suppose I am applying a force of 100 Newton on a body at an angle 30 degree from the ground. And I want to study the motion of the body in horizontal direction and vertical direction. They are mutually perpendicular. So I need to break this force into horizontal component and vertical component. That is where the need arises. Now, can you tell me if I want to break this A vector into these two mutually perpendicular components, what will be those two components? What will be the value? What will be the value? What will be the value? Let's assume this is going to be this direction. This magnitude is going to be X. This magnitude is going to be Y. We do not know their value. We want to find. What is going to be the length of this? Mod A. You know this?
Yes.
Mod A means the magnitude of vector A. In terms of this, I want to find X and Y. So once I am saying mod, that is the magnitude, right? Now, in this triangle, this is now a number, this is now a number, this is now a number. In this triangle, can I say cos theta? Cos theta will be what? X upon magnitude of A. Am I right? So X is equal to what? A cos theta. And what is Y?
Mod of sin theta.
Perfect. So now you know these components. So you can say this component of the vector in this direction. So direction we already know. This will be one direction. This will be magnitude of A cos theta. This component. And direction will be this as specified. And the other vector will be magnitude of A sin theta. And the direction has to be this. Now, if I say I am assuming this to be x-axis and I'm assuming this to be y-axis, so a unit vector along x-axis is denoted by I cap. A unit vector along y-axis is denoted by j cap. So can I say I can write a vector as, a vector can be written as in vector form magnitude of A cos theta. This is a number, right? Into I cap plus magnitude of A sin theta. This is again a number into j cap, a unit vector in that direction. Is that clear? Can I write this vector? On adding these two vectors, this vector and this vector, I'll get vector A. Am I right? So I have resolved this vector into two mutually perpendicular directions where one direction was specified that it is making an angle theta with this vector. So I broke it down. A cos theta along that direction, A sin theta perpendicular to that direction. And this resolution is called rectangular resolution of a vector. Please note it down. Rectangular resolution of a vector along two mutually perpendicular directions where one direction is specified. Where one direction is specified. Now the numerical part is going to begin. Yeah, I can repeat. This is the most important part from where the transition from theory to numericals will start now. So I'll repeat it. And I'm surprised that a lot of you do not have not done addition parallelogram triangle method earlier. Big shock for me, but must chapter, most important chapter, vectors. Every quantity will be vector. Abhi se shuru ho jayega. Kinematics, velocity, acceleration, displacement, everything is a vector, and we'll move there. While we want to practice question on vectors, we'll do those things. Practice bhi ho jayegi, wo cheeze bhi samajh mein aayegi. Fastest, smartest way. Be ready. I want to repeat this again. Please pay attention. I want to repeat this again. How many of you want me to repeat this again? Nice. Good, good, good. Major demand. Now, if I am given a vector A, which is here, what will be the length of this vector? Can I say it will be mod A? Right? Now, you know trigonometry, sin theta, cos theta. In this right angle triangle, this is going to be mutually perpendicular. I already told you that if I have specified that I want to break this vector into two vectors, one vector must be along this direction and the other vector has to be perpendicular to it, mutually perpendicular. So I can say if I break this vector into two vectors which are mutually perpendicular, one has to be along this, the other has to be along this, and I drop a perpendicular and I get these two will be those two vectors in which I'll break this vector. And on adding these two vectors, I will get this vector. How do I find them? Using trigonometry. Just cos theta definition. What is cos theta? Cos theta in a triangle is defined as adjacent side upon hypotenuse. So I just kept cos theta. Yeah. Cos theta is adjacent side upon hypotenuse. So adjacent side aage A cos theta. This is the magnitude. Right? But I know the vector will be in this direction. Direction I already know. Magnitude I have found out. What will be this magnitude? Same. Sin theta is what? Sin theta is opposite y upon A. So what will be y? A sin theta. Length I already know. Direction will be this. Now this vector, the magnitude I know, the moment I know, suppose I tell you I have a unit vector along x-axis, which is I cap. Now I tell you, I am going to have 100 Newton force along x-axis. What I have to do? Multiply it by 100. 100 Newton I cap. This will be a force along x-axis with 100 Newton magnitude. If I tell you I want 1000 Newton force along y-axis, what will I do? Into j cap, a unit vector along y-axis. This is a force which is 1000 Newton along y-axis. Now I knew the magnitude is this and it is along x-axis. मैंने assume किया this is x-axis and assume किया this is y-axis. Now can I say this into I cap is my this component? Can I say that?
Yes, sir.
And this into j cap is my this component. And on adding these two vectors, I will get this vector. So I wrote A is equal to A cos theta I cap plus A sin theta j cap. थोड़ा सा डाइजेस्ट हुआ,
Yes.
थोड़ा सा समझ में आया.
Sir.
We'll practice it more. Questions करते हैं. हाँ बोलिए.
So I cap and J cap are constants.
Unit vectors along x-axis, unit vector along y-axis, and they are constants. Constant in the sense they have a direction. They are just specifying a sense of direction,
Okay.
and their magnitude is 1.
So, sir, they don't have a value.
Their value is 1 unit.
One.
So I am coming to that. Let me explain this unit vector. Good. Sorry, I should. Sorry. Now, you may need these notes. Unit vector. Quickly. Unit vector. When I say I have a vector like this A, and I divide this vector by its magnitude, this will become a unit vector in the direction of it. Now, what do I mean by unit vector? It will be a vector which has magnitude 1 and it is in the same direction as this vector, but magnitude is 1. So suppose I say this is 100 Newton force in some direction, and that direction I'll keep intact, that vector, divided by 100 will give me a unit vector in this direction. Or let me say it another way. Suppose this is x-axis, this is y-axis, and I tell you, I have a unit vector, any one unit, वो ये है, which is I cap, 1 meter suppose. 1 meter is 1 unit. I cap is a unit vector in x-axis direction. And if I tell you I have a 50-meter displacement along x-axis, how will you write that? Can you write that? S displacement will be 50 I cap. Can you say that?
Yes.
So 50 I cap is, magnitude is 50 meters. And you multiplied it by I cap, which represents the direction along x-axis. And you can say displacement is 50 meters along x-axis, and that is S1. Right? Can I say, if I have a vector which is a unit vector along y-axis, I represent it by J cap. Can I say, if I have a force acting 20 Newton force, can I write that force as 20 J cap Newton? Newton is the unit. Direction is J cap. That force can be written like this. A force which is acting along y-axis has magnitude 20 Newton, can be written like this. You specified the magnitude, you specified the direction. So you are representing a vector. Are you getting all this?
Yes, sir.
Now,
So,
okay, let me give you an exercise based on this. Let me give you questions based on this. Just answer this. So we are assuming x-axis unit vector to be I cap, y-axis unit vector to be J cap, and z-axis, third dimension, will be K cap. Now, you have to represent a force which is along x-axis and has magnitude 100 Newton. Just write it down. This is one. Second, I keep writing, you write the answer. You don't have to copy the question. There is a displacement which is which is 20 meter towards east and 40 meter towards west. Third, represent a velocity in vector form which is having a horizontal component as 10 meter per second horizontally and 50 meter per second as vertical component. Now try to write these vectors, represent these vectors in vector form. You can decide east, west, north, south to be I, J, K. I and J, x-axis, y-axis. You can represent horizontal and vertical direction to be x-axis and y-axis. You have to specify that, what you are considering, and then write in terms of I and J. Give it a try. So in the first case, x-axis along 100 Newton. I have nothing much to think because he is already saying x-axis along. So what is a unit vector along x-axis that we is the convention I cap. So can I write a force which is along 100 Newton? This is the force and the direction is I cap. The moment I write this force, I have represented it in vector form. I have represented this vector form, force in vector form, which is very clearly telling anyone in the world, okay, you have a force of 100 Newton, and in which direction? X-axis. It is along x-axis. Anyone in the world will understand this the moment you write this. Now, you have to specify displacement east, west. So you have to specify which direction you are considering to be x-axis, which direction to be y-axis. You have to specify. So you have to draw a reference. Okay, I am going to assume this direction to be east, this to be west, this to be north, this to be south. All of you, if you stand towards east, face करके, तो ये east हो गया, तो मेरे पीछे क्या होगा? West. मेरे left में क्या होगा? North. Right में? तो वही हमने मान लिया. South अपनी इस side रखना है. Easy to explain to everyone. कि I have assumed this to be the sign convention, this to be the directions, and I am going to say this is x-axis and this is y-axis. You have to specify this. Huh? You can't assume, someone will assume what you were thinking in your head. So once you have specified this, now you can write this displacement in terms of I cap, J cap. What will be that? Minus 20 I cap or 20 I cap? Why were you saying to minus 20?
It's going towards west. It's going towards the negative x-axis.
This is east.
40 meters west.
Same, but negative.
Good.
Negative.
I never make mistakes. I make intentional mistakes. Learn this about me. So, चाचा चौधरी का दिमाग कंप्यूटर से तेज चलता था. मेरा दिमाग चाचा चौधरी से भी तेज चलता है. And I never make any errors, mistakes. I make intentional mistakes to check whether you are attentive enough or not. Now, so you will write this displacement as 20. Displacement will be 20 I cap. Yes. Minus 40. Can I say this will be minus 20 I cap?
Yeah.
Yes, when vectors are acting along same direction. And you can see that. I'll explain. Suppose I moved 20 meters towards east. So I went 20 meters like this. This was my initial point. Then he says I went 40 meters towards, I went 40 meters towards west. So I started walking towards west and went 40 meters like this. I reached here. This is my final point. Now, what have I told you? What is the definition of displacement vector? बताइए. Vector joining the
Initial point and final point.
this vector will be the resultant vector, and that is minus 20 I cap. Correct? Got it? We wrote it. Velocity of 10 meter per second in horizontal direction, velocity of 50 meter per second in vertical direction. I want to write it. So which directions are you going to take as horizontal and vertical? X-axis is horizontal and y-axis is vertical. So now what can I write? Velocity v vector 10 I cap plus. If I tell you raindrops are falling vertically downwards, what will you write? Velocity of raindrop, and that is 100 meter per second se gir rahe hain. Minus 100 J cap. If I tell you raindrops are falling at an angle, which has 100 meter per second component in vertical direction and 50 meter per second in this direction, how will you write those raindrops velocity in I? Minus 50 I cap minus 100 J. Wow, मजा आ गया. So ये सब हमारा relative velocity में काम आएगा. Now you are getting the hang of it. Good, good, good. Now let's begin. अब आएगा. Now we are shifting from theory to numericals. I have a vector A I have another vector B and this angle between the two vectors is theta and I want to find their resultant numerical. What do I do?
Parallelogram.
Or triangle method, whichever, but their tails are kept together. Which one will be? Perfect. आप सब लोग प्रॉपरली ट्रेन हो रहे हैं, कुछ सोचना ही नहीं है, वरना बच्चे कंफ्यूज्ड ही रहते हैं, भाई क्या लगाएं दोनों में से. कोई बोल देगा ट्रायंगल मेथड इज बेटर, कोई बोल देगा पैरेललोग्राम इज बेटर बिकॉज द एंगल इज व्हेन देयर टेल्स आर टुगेदर एंगल इज मेंशन्ड इज राइट. भाई कोई फर्क नहीं पड़ता. नो, एनीवेज, आई वांट टू फाइंड द रिजल्टेंट ऑफ दीस टू. This length is magnitude of A, this length is magnitude of B. Am I right?
Yes.
This angle is theta. If I extend it a little like this angle will be theta. Yes or no?
Yes, sir.
This length will be how much? Is it right? If I drop a perpendicular here, what will be this length? Quick.
Mod A cos theta.
All of you know this? A cos theta. What will be this length?
Mod A sin theta.
Lovely. Mod A, you have to be very, very alert about what you are talking about for some time. Later, when you become experts and you know, okay, I am Praveen Tyagi, then you can skip A sin theta, A cos theta. But right now, you have to be mod A. Magnitude.
Anybody performs from the
Praveen Tyagi is. Oh, you heard that story or not? You came late. I'll tell you. Some people heard that story in the body. No, you came late.
Not today, sir. उसमें
That गधे वाली story.
बस नहीं होनी चाहिए.
सबसे इंटरेस्टिंग स्टोरी है. कितने लोगों को इंटरेस्टिंग लगी जो सुबह सुबह आ गए थे उन्हें सुनाई थी, जिनको मैंने आज मॉर्निंग में सुनाई है.
Sir, the stick one.
ये अलग है, ये बहुत इंटरेस्टिंग स्टोरी. इंटरेस्टिंग लगी या नहीं? ब्रेक में सुनाऊंगा, मजा आएगा. नाउ प्लीज कम हियर. सी वी आर वेरी क्लोज टू बिकमिंग न्यूमेरिकल. थक मजा आएगा. ध्यान से देखिए. कैन आई से दिस टोटल लेंथ इज हाउ मच? This plus this, and this total length is this. So do I know this hypotenuse? Yes or no?
Yes.
And that is the resultant. So can I find the magnitude of resultant?
Yes.
Sir.
What will that be?
Root of
Pythagoras theorem. Root of this square plus this square. What is
the mod B.
a square sine square theta plus b plus a cos theta, है ना?
Mod B.
b plus a cos theta whole square. And this is r square. Pythagoras theorem. And r will be, this is a result which many people tell you, cram it. I am telling you, just understand it. You can remember it. So you will be using it many times. So root of, when I simplify it, it will be a square, b square, a square cos square theta. Am I right? Plus 2ab cos theta. So a square sine square theta plus a square cos square theta will become what? 1. So a square. Then you'll have a term b square. And all these are magnitudes. Huh? A square plus b square plus 2ab cos theta. This is the magnitude. And where theta is the angle between the two vectors. And am I right with that angle? That angle is when their tails are kept together. Correct, huh?
Yes. This is also the law of cosines, no?
Cosine rule. You just square it, find cos theta. There'll be like this square minus. You will find cos theta. That is called cosine rule also. This is the derivation. Pythagoras theorem se humne nikala. Got it?
Yes, so
So you will remember this result. Yes.
order to get a square.
Oh, how did I get square? Let's do it. Let's do the hard work. Never skip the hard work. Beginning hai. Aage, I'll expect you to be running with rocket speed, but right now I can give you this liberty. First day. A square sine square theta plus, let's open this bracket, B square plus A square cos square theta plus 2AB cos theta. You just saw this line. Now this plus this, A square will come common. What is sine square theta plus cos square theta? 1. So it becomes A square plus B square plus 2AB cos theta. Every book has this derivation. Don't make me do all this labor work.
But you only wanted to do order to
I want you to develop that confidence and clarity. It shouldn't be that you were cramming some formula. You should know how it was arrived at. Got it?
Yes.
Now, so now we will remember this result. It's so easy. If there are two vectors A and B, and the angle between the two vectors is theta. And what do we mean by angle between the two vectors?
Smaller angle between the tails.
When their tails are kept together. If by any chance I try to confuse you or play with you, and I say this is vector A, this is vector B, and the angle, this angle is given as theta. Can you use this formula right now? What will you do? What correction will you do?
Bring
Bring the tails together. And you shift it here. You brought the tails together. And this angle will be called angle between the two vectors phi. Am I right? Now, phi can be written as 180 minus theta. So, in this formula, what will you use if this angle is theta? Is formula mein will you use to theta or will you use 180 minus theta? Simple, and you get the answer. If suppose he tells you, I have a vector here A, I have a vector here which is heads are together, ऐसे, and then he gives you this angle. What will you do? You will always go to the basics. I told you how to define the angle between two vectors. Because in this formula, what is theta? The smaller angle when the tails are placed together, and that is called as angle between the two vectors. Angle between the two vectors. If he is trying to give you any other angle and trying to confuse you, you will go back to the basics, bring the tails together, find out what is the smaller angle, and in terms of that, you will write that angle. जो हमें चाहिए इस फॉर्मूले में वो एंगल आएगा. And what is that angle? Angle between the two vectors, and we have defined that, made you drilled that into your head. What is going to be the angle between two vectors? Are you clear? So if it gives you any other angle, you have to be careful and find out that angle which we are referring to in this question. Is it clear? Clear? I can play with questions, but right now, instead of going into the theory, into the questions, I want you to understand one more thing. What will be the direction? You cannot be happy without telling you cannot be done with anything in a vector unless resultant magnitude you have told me. You haven't specified its direction. ये जानबूझ के किया हमने. टीचर भी नींद से जागता रहे पढ़ाते हुए, attentive रहे. हाँ. So everything is well thought. Now, this angle, suppose alpha. The resultant makes an angle alpha with B. What will be tan alpha? This upon this whole thing. What is this whole thing? B plus A cos theta. What is this whole thing? A sin theta. So tan alpha will be what? A sin theta upon
Plus A cos.
if suppose I tell you ulta, I tell you I want this angle beta. So you know, without solving it using the same symmetry, I can say tan beta will be b sin theta upon a plus b cos theta, because there is no differentiation between a and b. If when you are finding angle with a and you are getting these terms, so angle with b, a should be replaced because of symmetry. I can say that, and you can do the calculation, you can do the projection, and you will still get the same answer. Are you getting all this? So we derive two important results which should be on your tips, and they help you do questions faster. Bus, that's it. Don't cram too much, but remember these two results if possible will help you. Otherwise, we'll always stick to basics. I'm not in favor of cramming too much, but these two results are important. Let's see. JEE मेंस वेंस उन्होंने ना बहुत एनसीईआरटी लेवल बना दिया, और उस चक्कर में दे डू गिव क्वेश्चंस बेस्ड ऑन फॉर्मूले. अनफॉर्चुनेट है ये, पहले नहीं होता था. आईआईटी में दे ऑलवेज यूज्ड टू गिव, कुछ रटना ही नहीं होता था. आजकल थोड़ा मेंस में परफॉर्मेंस चाहिए तो रट्टू तोता बन जाओ थोड़े और सारे एनसीईआरटी के फॉर्मूले मांग लो, यू विल गेट अ ग्रेट परसेंटाइल. ये हो रखा है, अभी आपको रियलाइज होगा. नाउ आर वी डन विद दिस? नेक्स्ट. They were supposed to put some questions on my screen, PYQs. I don't know where that is. Where is our coordinator? Anyway, coming now. So the result. If I just tell you there is a vector A, there is a vector B, and these two vectors, the angle between the two vectors is theta, and you know what do we refer? What do we mean? What is the convention? What do we mean by theta? All of you are aware? What is that theta? Angle between the two vectors when their tails are together, and that too simple. Done. Now, if A and B are given magnitudes and theta is the angle between them, find the resultant. What will be the resultant? Quick. Root of? Perfect. And if I tell you I want the angle with tan alpha, angle which the resultant makes with vector A.
What is sin theta? A sin theta upon. What is
Where is it? Tan alpha. A sin theta. Okay. I'm so sorry. Intentional mistake. What should I write? If you are finding angle with A, it'll be. I wanted to drill this into your head. That's why I made this mistake. A sin theta upon B.
cos? A.
Yes. This is the angle which the resultant makes with vector A. If I want to find the angle which the resultant makes with vector B, tan beta will be B sin theta. Got it?
But you are taking alpha and the angle between B and
Alpha is the angle between resultant. Oh, this intentional mistake. What was this angle with? V. So this formula is, I remember the result. That is why I was writing. So angle alpha, which it is making with vector B, is this. ठीक है? So वो गलती से हमने आगे A लिख दिया और that's why I got puzzled. ये देखिए. So this alpha is angle with which it makes with B. पता मैंने इसे याद कैसे किया हुआ है, रखा हुआ है. और मैं पहले अभी राइट है ना ये, तो जिसके साथ एंगल बनता है ना वो एक बार आती है टर्म, जिसके साथ एंगल, ऐसे मेरे याद था. सो थोड़ा कंफ्यूजन हो गया, बट ठीक है. Are you clear? I am not very good at mugging formulae and I do not want you to be mugging formulae, but unfortunately JEE Mains ऐसा बना दिया है, no option. So these two results you have to remember. हाँ.
So someone said the first equation is like law of cosines. But so in law of cosines there is a minus not a plus.
Find cos theta. Find cos theta.
It's a square plus b square minus 2ab cos theta.
हाँ.
Because someone earlier compared it to law of cosines.
1 second. We are coming to that. Interesting thought. Let me go to the. Should I rub it? Okay. So this is the resultant. Resultant R. What do we mean by that? So I have a vector A. I have a vector B. A, B, and the third side is resultant. Now, what the child is saying is कि भाई ये angle theta है. This is what we meant by theta. And this child is saying कि cosine rule नहीं लग रहा. भाई cosine rule में you take, suppose these are the three sides A, B and R. So you will take which angles?
180 में.
This angle. तो वो माइनस वाला कॉम्पोनेंट वहां से आ जाएगा. यहाँ पे हम कौन सा एंगल ले रहे हैं? ये वाला एंगल ले रहे हैं. When their tails are together. Are you getting it? So don't worry about. अभी मैथ्स पे मत जाओ, अभी फिजिक्स पे रहो. फर्स्ट स्ट्रेंथन योर फिजिक्स कॉन्सेप्ट्स. मैथ्स तो जब आप पैरेलल में करेंगे ये सब थीटा वीटा खेलना सब समझ में आ जाएगा. डोंट वरी अबाउट इट. एंड पता है व्हेन आई वाज इन बिगिनिंग ऑफ 11th आई यूज्ड टू ट्राई टू प्रूव न्यूटन्स लॉज रॉन्ग. I used to keep thinking about how can I prove him wrong. वो भी तो इंसान था, मैं भी इंसान हूँ, मैं भी सोच सकता हूँ. Later I realized that these scientists and laws that are accepted by scientific community, they are well researched, debated, then accepted, proven in laboratories. So a child like me who is in 10th going to 11th should not be trying to prove. ये चीज मुझे बहुत लेट समझ में आई, but it was fun. When you are roaming around with a thought कि न्यूटन को ही चैलेंज कर दूंगा, it's fun. In a village, a boy, उस चक्कर में और ध्यान से पढ़ता था. मिल जाए लूप होल, ठीक है. लेटर समझ में आया कि लूप होल्स डोंट एग्जिस्ट एंड द साइंटिफिक कम्युनिटी हैज वर्कड हार्ड अ लॉट. सो इस तरह का कोई भी चीज कभी इलॉजिकल मिलेगी नहीं आपको कहीं कि कोसाइन रूल में कुछ गड़बड़ हो गई या यहाँ कहीं कुछ हो गई. बट यस, यू नीड टू बी क्लियर. हाउ आर वी रिलेटिंग? इज इट एक्चुअली कोसाइन रूल? इज इट नॉट? विद दैट डिस्कशन वी गॉट दिस क्लैरिटी के in cosine rule you deal with this angle and this angle, right? So when you write cos theta, cos phi, you will write what? Cos phi will be what? बोलिए. This square plus this square minus this square upon 2ab. यही लिखेंगे ना? Am I right? So you'll write a square plus b square minus r square upon 2ab. This is what is cosine rule. Am I right, beta?
So I was not pointing out that the law of cosines is wrong. I was just pointing out the relation of
हाँ.
it was wrong.
आपके उस बोलने से we are getting clarity now. This discussion wouldn't have happened had you not mentioned that. Now, just see this. This is cosine rule. Now, how is cosine rule and triangle method vector addition? How are they related? Let's try to understand. Now, from here, if I find out r square, what will r square be? A square plus b square plus 2ab cos phi. So maybe cos 180 minus phi is same as cos theta. Let's see. A S T C. 180 minus theta. 180 cos 180 minus theta is same as minus cos theta. So correct है या नहीं है? हाँ, ठीक तो आ रहा है. ठीक आ रहा है. Got it? चलिए. Now,
Sir,
Ah,
law
anything related to this?
law of cosines कब सीखा मतलब कि
Later maths में आएगा. Sine rule, cosine rule, all this. Now coming back to vectors. So there are vectors which are like displacement, axial vectors also I want you to know, because in physics, rotation, circular motion, everywhere, you need to know this. So what are axial vectors? So when you are dealing with rotation, suppose this body is rotating like this. A point mass is going in a circle and it is rotating like this. This way. This angle is theta, time taken is t. If I define average angular velocity, this will be like theta upon time taken, and that will be angular velocity. But what is the direction of angular velocity? So, and this is anti-clockwise or clockwise?
anti-clockwise.
Anti-clockwise. So, please tell me, what is the direction of this angular velocity? Anti-clockwise तो word में लिख दिया. Anti-clockwise में एक problem है. नहीं, anti-clockwise में एक problem है. ये बताइए, is it rotating anti-clockwise or not? Yes or no? Right? लेकिन if you see it from my side, clockwise. So ये anti-clockwise और clockwise तो confuse नहीं रहेगा. आपको तो यही नहीं बता पाएंगे कि इधर से देख रहे हैं तो वो anti-clockwise दिख रहा है, इधर से देख रहे हैं तो same चीज, same motion clockwise दिख रहा है. So ये anti-clockwise, clockwise को इसलिए discard किया गया. And we decided to assign a direction to omega, and that is according to right hand thumb rule. Right hand thumb rule क्या है? Curl your fingers in the direction of motion. The thumb is the direction. So omega की direction क्या है बताइए यहाँ पे?
Out of the plane.
Out of the plane. So we will say out of the plane. Oh my God! अब जाओगे. It is touch. So out of the, oh my God, can we? No. No, I was getting ideas. This.
Yeah.
Out of the plane is an arrow which is coming out of the plane. If you see the side view, arrow, pointed arrow. Arrow आपने देखा है ऐसे होता है. Da-da-da-da-da. किसको आता है arrow बनाना? ऐसे कुछ कुछ होता है. आपने रामायण देखी है राइट? ऐसे. अब आप इस एरो को इधर से देखेंगे तो आपको ऐसे दिखेगा, एक पॉइंट एंड सर्कल. आप इस एरो को पीछे से देखेंगे ऐसे दिखेगा. एरो अंदर चला गया. सो टू रिप्रेजेंट डायरेक्शंस which is coming out of the plane, we make this symbol, a dot, and direction into the plane, arrow. Can you tell me what is the direction right now? So omega will be in this direction. उसको आप ऐसे दिखाइए, या उसको आप इस डायरेक्शन को अगर z एक्सिस बोल दें तो k कैप बोल दीजिए, इस डायरेक्शन को x एक्सिस बोल दें तो i कैप बोल दीजिए. Whatever you decide. Is that clear? So now, if I have a rotation going on, the direction will be along the plane perpendicular to it. If the direction is happening in this direction, what will be the direction of vector omega? Omega की direction क्या होगी? Upwards. This will be the direction of omega. If this same direction, same motion was happening in this direction, clockwise, then the direction of omega will be downwards. All of you clear about it? Now.
So can you please repeat the definition of omega?
Yeah, angular velocity. Very catchy area. Rotation पढ़ेंगे तो समझ में आएगा, but अभी इतना समझ लीजिए. How do we define velocity? Displace speed. Speed is distance covered upon time taken. Velocity is angular velocity is angular displacement upon time taken. So angular displacement is theta. Angular displacement is theta upon time taken is delta t. So this is, I just wanted to focus on the direction part, that's why. Now there is a game here, and this girl asked this question, though I'm a little suspicious that she is aware of all that. So what is the game? Is angular displacement a vector or not? Angular velocity is a vector. All of you are aware? Linear velocity, displacement is a vector. Linear velocity is a vector. All of you are aware of this. Angular velocity is a vector. You must have heard that. We are talking about its direction also. But angular displacement, is it a vector or not? This is a question. Note it down. Is angular displacement a vector? This is food for thought. Malar, can you answer this?
I think no.
Think no.
Yeah.
Or you know that it is a no. ठीक है. So this is an important concept, and we can prove that finite angle is not a vector. I'll prove it. Suppose I have two vectors where theta 1 is a finite angle and it is 90-degree rotation about x-axis, y-axis, z-axis. So I am saying there is an angular displacement of 90 degrees. 90 degrees and anti-clockwise, suppose. And then theta 2 is an angular displacement of 90 degrees about a certain axis. तो मैं पहले बोलता हूँ along I cap. मतलब डायरेक्शन नहीं दे सकता, वही तो प्रूव कर रहा हूँ कि डायरेक्शन नहीं होती है. देख लीजिए. Just see this. This is the initial position of this book. ठीक है, ऐसे रखिए. Now I am going to give it two finite angular displacements. One is going to be, the first angle will be, I will rotate it by 90 degrees about this axis. According to you, it is clockwise? Clockwise. So 90-degree clockwise displacement about this axis. Clear? So let's do that. 90-degree clockwise direction about this axis. Now I'll give it a 90-degree clockwise direction this wise, this with this axis. So ये कर दिया. ये final position हो गई. ये final हो गई. Theta 1 plus theta 2 is this. अब हम फिर से वापस original position. अब हम theta 2 plus theta 1 करते हैं. Vectors में a plus b is same as b plus a, right? Let's see. Let's first give it. So initial position was this, and what was the final position? Let's see. We first did, I'm repeating again, we first did 90-degree displacement about this in clockwise direction. This was clockwise. And then I did 90-degree about this axis in clockwise direction. This is where we reached. So this edge and flat. Got it? Now let's see the other case. Theta 2 plus theta 1. First, I'll turn it 90-degree like this. Are you getting it? 90-degree about this axis, clockwise. Yeah. Now let's turn it 90-degree about this, clockwise. Is theta 1 plus theta 2 same as theta 2 plus theta 1? No. So finite angles are not vectors because they are not following commutative law. And we are defining angular velocity as a vector. Where is the catch? You have to go and hunt and read textbooks and tell me in the next class. Is that clear? So I thought you already know this game. Oh, अंधेरे में तीर लग गया. चलो, anyways, अच्छा है, ये concept discuss हो गया. Now, alert. So I just told you that finite angles are not vectors, and still we are defining angular velocity as a vector. We'll come to this. Very important about rotation, circular motion, and that's like the climax of full mechanics. We will be reaching there. Right now, today is the first class. I don't want to go too deep into futuristic topics, Abhi. Let's stick to the thing that we are doing. Do you need a break? So now we are coming to vectors and addition we learned. Triangle method and parallel method. Good. And we also learned how to find the resultant and Unfortunately, my team didn't know about the lecture. Otherwise, they would have kept the questions ready. जो previous years IITs में आया ना, जो mains में आए हैं, and you would have easily been able to solve those questions in the next lecture कर लेंगे. ठीक है? Now, and you will find it's not rocket science. उतना tough नहीं है कुछ भी. बहुत easy है. Now, alert, attentive. If I now let's start. Okay. If I want to, there is a vector A. There is another vector B. What will be the resultant? A plus B? Which method? This is A plus B vector. This is another new vector, which is A plus B vector. Now I have a vector C. We are coming there. This is vector C. If I add A plus B and C, this will be a new vector. What will that vector be? A plus B plus C, and that vector will be this. This is A plus B plus C, this vector. If this vector is added to another vector, which is D, then this vector will be what? A plus B plus D. Please understand, unless I write this vector sign, you are talking about magnitude. And this will keep going on. And suppose I have got n vectors, A1, I can say this is A1. This is A2. This is A3. And so on. And I have n vectors, and this is like the nth vector, suppose an. Now, this vector will be this vector. They are together. Huh? This vector will be what? A1 plus A2 plus A3 plus A4, an, and this is the resultant vector. Are you clear? So I can say this is called law of Polygon law of vector addition. So if you just keeping the tail of one on the head of another and keep adding those vectors, and you have n vectors. So A1 plus A2 plus A3 plus an, they represent the sides of a polygon. Then the last side in reverse direction. Initial point will be this only, jahan se begin kiya. This side will represent the resultant, and that resultant will be A plus B plus, this will be R resultant. And this is called Polygon law of vector addition. So you had triangle law, you had parallelogram law. This is called polygon law. Now, let's play with these vectors a little bit. Suppose I have a triangle, I have a vector A, I moved in this direction, then I moved in this direction, and I reached back here. So this is vector A, vector B, vector C. What can you say about A plus B plus C? A vector plus B vector plus C vector. What is the resultant? Yeah. Because initial point was this, final point is this, displacement is 0. Suppose these were displacements. Very easily you can see, if I just say A plus B is equal to what? Minus C. So what is minus C? C is this vector. A plus B plus C is 0. So A plus B is equal to minus C. Minus C is this vector. And what is this? Triangle method of addition. A vector plus B vector gives you the resultant. Third side gives you the resultant. And that is equal to minus C, which is the third vector. And getting it? Now, if I write some expression, will you be able to identify what is happening there? Suppose I tell you there is a vector A, there is a vector B, and there is a vector C. They may not be equal. I've drawn the diagram to be equal, but they may not be equal. A B, and C are vectors. And I'm making the direction. Just don't assume it is in the, this is this, and this is this. What can you write? What is A plus B is C? I can give you 4 options. A plus B is C, B plus C is A. What is the case?
A plus C is B. A plus C.
Be attentive. Tell me. A plus
C.
C plus A is?
B.
Yes. C plus A is B. Because for this vector, you have the tail of this vector on the head of this. So this plus this will give you this vector plus this vector will be this vector. So we can write B is equal to what? A plus C. Nothing else. No other way. Clear? Now, so attentiveness will give you more clarity. You should have error-free thought process. That's what you have to achieve. Going, attempting a question, getting stuck, this is natural. This will happen. But when you write one line, when you write one word, when you write one equation, it should be correct. Or we are thinking about it. I want to develop that kind of thought process in you. Are you getting it? Now, I am going to give you some questions and let's see how will you respond. So there is a body which is being thrown at an angle theta with the ground. This angle is 30 degrees. And I'm going to throw a stone with 100 meters per second at an angle with the ground. Will this body go in a straight line?
No.
It'll go like this and it'll go and fall somewhere like this. Right? This kind of motion is called projectile motion. You may have heard it, may not have heard it, doesn't matter. Are you getting it? Can you tell me if this was the initial velocity of this initial velocity was 100 meters per second. I want to write it in terms of what was the horizontal component and what was the vertical component of this velocity initially. So this will be horizontal component, this will be vertical component, right? Can you tell me what was the horizontal component? What was the velocity along the horizontal direction initially? I can break this vector into horizontal and vertical components. What is the horizontal component? 100 cos 30. So this component will come out to be, so we learned that there is a vector A, it's making an angle theta with any direction. So we knew what was the component in this direction? A cos theta. And what was the component in this direction? A sin theta. So what was its initial horizontal velocity? Quick. 100 cos 30. What was its initial vertical velocity?
50.
Initial vertical velocity was 100 sin 30. And for the further motion, I will study the motion, no issues, later. Right now, I just want to highlight to you can you write this velocity? It's a two-dimensional plane. It has some horizontal component. It has some vertical component. Initial velocity was at this point. Immediately after this point, the velocity will start changing. Am I right? Can you write this initial velocity as a vector as 100 cos 30 I cap? If I'm assuming this to be x-axis and this to be y. So can I write this as I cap plus 100 sin 30 j cap? Can I write this?
Yes.
Perfect. This is the right way of writing a vector. Perfect. Now, just out of curiosity, when this body is in air at any point, what is the force acting on this body?
Gravitational and wind resistance.
Gravitational? mg, downwards. Am I right? Earth is pulling it down with this force. Is there any horizontal force acting on this? I am assuming air to be frictionless.
No.
There's no horizontal force. So all the time when it is in air, the force that is acting is in which direction?
Vertical.
Vertical direction. So when there is no force in horizontal direction, will the velocity in horizontal direction change?
No.
It will not change because there is no horizontal force. So the horizontal component of the velocity will not change at all. So initial horizontal velocity was this. Will this velocity remain same every point? What is the velocity horizontal at this point? 100 cos 30. What is the horizontal velocity at the highest point? 100 cos 30. What is the velocity just before hitting the ground in horizontal direction? It was always traveling with 100 cos 30 in horizontal direction with a constant velocity because there was no horizontal force. So this direction velocity remained unchanged, constant. If it was in air for t time, horizontally, what will be the displacement? Horizontal velocity into t time, because velocity was constant. That is called the range. This is called the range. Just making you aware. It's a separate chapter called projectile motion, full chapter. But this much is the basic. And what is the range equal to? Horizontal velocity, which remain constant, into time of flight. Simple. It is that simple. And for vertical motion, we will study it using equations of motion because it has acceleration. Acceleration is g downwards. We will study that kinematics में पूरा chapter होगा. So ये बहुत लंबी कहानी है. Right now, I just wanted you to get a feel. We broke the initial velocity into initial horizontal component, initial vertical component, and we learned this is the initial horizontal component of the velocity. This is the vertical component of the initial vertical velocity of this velocity. Is that clear? That's it. The purpose is to be aware till here. All this you will learn as a separate chapter in projectile motion and you will find it easy. Now, we are playing with vectors. Objective is to understand vectors. I have an inclined plane and a body is falling on this plane and this plane is making an angle theta with the horizontal direction. I am going to keep a block on this and the block has a mass m. Frictionless surface, no friction anywhere. How will this block fall? Parallel to the surface. Now the motion will happen parallel to the surface. And what is the acceleration in perpendicular direction? 0. It is not penetrating the block. It is not jumping up. So in this direction, what is the acceleration of this mass? 0. And the only velocity or acceleration it will have will be along the plane. So in such cases, we study the motion parallel to the plane and perpendicular to the plane. In such cases, you have to break all the forces, accelerations, velocities parallel to plane and perpendicular to plane. When in projectile motion, you were studying the motion in which two directions? Horizontal direction and vertical direction. Why I decided to choose horizontal vertical? Because in horizontal direction, there was no force. In vertical direction, there was acceleration due to gravity. So I knew things in vertical direction, I knew things in horizontal direction. I chose those two directions. In this case, I know for a fact that acceleration in the direction perpendicular to plane will be always 0. It will only be parallel to plane. So I know information. So I will break this motion into which two directions? Parallel to plane, perpendicular to plane. So it becomes necessary for us to break any force. And suppose in this case, I tell you, gravitational force is the force which I want to break in two directions. So mg is the force which is acting like this. Earth pulls any object downwards. So what are the two directions I want to break it in? Parallel to the plane and perpendicular to the plane. Now, if this is theta, this is 90. What is this? 90 minus theta. If this is 90 minus theta, what is this? 90 minus theta. If this is 90, what is this angle? Theta. So what is this angle? Theta. Now, can you tell me what will be the component of this force perpendicular to the plane? mg cos theta. Yes. So this will be the component of this force in this direction will be, we learned this, A vector, A cos theta. And what will be this component? Mg sin theta. And that's it. I wanted you to learn how to break. That is why we learned resolution of forces, resolution of a vector. Because when we know two directions in which some information is given, we will study the motion in those two directions. So we will need to break vectors in those two directions. So we learned we can break this mg force. Now, just to give you a brief idea, even though it is not needed at this stage, there will be some normal force acting on this block or not?
Yeah.
The contact force, normal force will be N1 in this direction. The force which this block, this wedge exerted on this block. This block will exert equivalent opposite force on this. Yes or no? There will be N1. And this whole thing will be in Newton's laws of motion, free body diagram later. I am not going to do that right now. Just giving you a glimpse. And when you will reach those chapters, you will find, अरे त्यागी सर ने ये सब तो पहले ही बता दिया था. Connect होंगी हर चीजें. अभी बस सुन के, देख के. Right now our purpose was breaking this force into two mutually perpendicular directions. And this direction was how much? The component in this direction was mg ka component in this direction is, if this angle is theta, mg cos theta, and in this direction it is mg sin theta. But that's it. This was the objective of doing this. Right now, don't get confused, don't get scared. Kitni complicated terms. Trust me, if you start understanding one step more, you will be doing IIT problems, advanced problems. We are that close now, inching close. Now, understand this. If I have a force which is 10 I cap plus 2 j cap, this is a force acting on a point mass. And this force gives this point mass a displacement. And the displacement of that particle is 20 I cap minus 30 j cap. What will be the work done?
F is cos theta.
F dot S.
Dot.
So now we are learning a chapter called work, energy, and power. And work done by a force is defined as, note it down. ऐसे curiosity के लिए, getting a glimpse into the future. F dot S is defined as the work done by a force. And that is equal to W, work done by the force. And this dot product we will be learning right now. And where, please understand this definition properly. Work done by a force is defined as F dot S, which will be magnitude of F, magnitude of S, cos theta. And it will be a scalar, and that is defined as the work done. Where? Now, जब सीख रहे तो S को समझ लेते हैं. Is S the displacement of the center of mass of the body, or S is the displacement of the point of application of force? Wow, I'm impressed. If you know this. Body कैसे भी move कर रही हो, उसका center of mass कहीं भी जा रहा हो, we don't need to bother. Point of application of force and displacement of the point. S is what? Please note it down. S is what? Quick. Reply. Displacement of the point of application of the force. That displacement you have to use here, not the center of mass of the body ka displacement. Sometimes if the body is rigid, it's moving in a straight line, then, and it is not rotating, then the center of mass displacement will be same as point of. Now, I have a question. I'm walking on a rough surface. There's no slipping. Is there a friction force acting on my feet and the ground? Yes or no? First of all, you have to tell me if I'm running in this direction. What is the direction? This is east. This is east. Friction force acting due to the ground on me will be in which direction? Praveen Tyagi died of heart attack tomorrow's Times of India front news page because students
Yeah.
answered wrong. He took a rebirth and decided to take revenge from those students who killed him with their answer. अज्ञान कितना है इस दुनिया में? अज्ञानता की हद है, पराकाष्ठा। भाई क्या बात कर रहे हो? ये नहीं सीख के आए हो? कौन से स्कूलों में पढ़े हो? कौन से? बंद कर दो उन स्कूलों को। बॉम्बे, स्कॉटिश, कैंपियन, चैंपियन। अभी स्कूलों का ही नाम चेंज कर दूंगा मैं। कैंपियन का कुछ और रखते हैं, सोचते हैं थोड़ा। हाँ सुनिए, प्लीज अंडरस्टैंड दिस थिंग। हैव यू हर्ड ऑफ माइकल जैक्सन? हैव यू हर्ड ऑफ मून वॉक? हु टॉट हिम मून वॉक? ही यूज्ड टू गो टू अ कोचिंग क्लास. This is not a joke. Which was the best coaching class of that time in US? Can you tell me the name? Let me check your general knowledge. Pace. Yes, good general knowledge. And he was a student of the best teacher in the world. I'm alive. He taught him how to do moonwalk. It's all physics. There's nothing in it. I told him, Mikey, you just assume you are standing on a ice slab, frictionless surface, and then you try to walk. And he tried to do that. You try to do that. You cannot walk. You will keep doing what he is doing. He used to do it in style. If this is not slippery enough, it's rough. I'm not able to do. Otherwise, what action is he doing?
Walk.
He's trying to walk and he's not able to walk. His feet are sliding. And that's called moonwalk. हवा में चलने की कोशिश करो. Can you push your feet? Can you walk? You can't. So, bhai, if I stand on a frictionless surface, if I stand on an ice slab, and if I try to walk, I will be doing moonwalk. Are you getting it? घर जाके try करना सब लोग. Now, if you study the two surfaces, one surface is my feet, the other surface is the ground, right? What is the action that is happening when my feet are trying to walk? I am trying to push the ground behind. The ground will push me ahead. And because of that push, because of that friction force, I am able to run or walk. So if I'm running towards east, the friction force due to the ground is acting on me in which direction? अब क्लियर हो गया? अब सब अपने 10th के फिजिक्स टीचर को मिलने आना और उससे ये क्वेश्चन पूछना और उसको ये सिखा के आना जिससे आने वाली जनरेशन को ये सब क्लियर रहे. Is that clear? Subtly, without offending him, politely explain this to him. तो वो जो न्यू बैचेस पढ़ाएगा उनको तो ठीक पढ़ा दे. नो, ध्यान से सुनिए. Alert रहिए. So if I'm running towards east, the friction force acting due to the ground on me is in which direction? Now, getting normal. Now we were here. Now the ground is exerting some force on me. Can you tell me if I am having a mass? So let's say that friction force that is acting is say 100 Newton on me. I'm telling you the value. 100 Newton is that friction force which is acting between my feet and the ground is making me accelerate and I'm running. That force is making me run. And I have traveled a distance of 200 meters भागते भागते. With this horizontal force, friction force जो ground ने मेरे पे लगाई. What will be the work done by this force? Force भी मैं इधर भाग रहा हूं, ये मैं इधर भाग रहा हूं, मेरे पे जो ground friction force लगा रहा है वो है 100 Newton and displacement मेरा हो गया 200 meters. What will be the work done by this friction force on me? Praveen Tyagi again died of heart attack. दीज आर कॉल्ड फंडे क्लियर होना, बस यही क्लियर होने हैं, पूरी मैकेनिक्स आ जाएगी, पूरी स्ट्रांग हो जाएगी, यहीं पे अटकी रहती है कहानी। फोर्स डॉट डिस्प्लेसमेंट सबने पढ़ा है, फोर्स भी दिख रही है, डिस्प्लेसमेंट भी दिख रहा है। अब यहां पे आइए, डिस्प्लेसमेंट ऑफ द पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स तो हो ही नहीं रहा है, वर्क डन बाय द फ्रिक्शन फोर्स विल बी जीरो, फोर्स भी है, डिस्प्लेसमेंट भी है बॉडी का, बट पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स पे जाते हैं। देखिएगा, मैं रन कर रहा हूं, मेरा पैर यहां पे है और मैं पुश कर रहा हूं, फ्रिक्शन फोर्स लग रही है पैर पे, बट डिस्प्लेसमेंट हो रहा है क्या उस पॉइंट का? जिस पॉइंट पे फ्रिक्शन फोर्स लग रही है उस पॉइंट का डिस्प्लेसमेंट हुआ क्या? अभी यहीं रखा है, और जिसका डिस्प्लेसमेंट हो रहा है वो हवा में है, उस पे फोर्स नहीं लग रही। अब मैं आगे गया, अब ये रखा, अब वो फ्रिक्शन फोर्स जीरो हो गई। डू यू गेट इट? सो द डिस्प्लेसमेंट ऑफ, जहां पे पॉइंट ऑफ एप्लीकेशन ऑफ फोर्स लग रहा है उस पॉइंट का तो डिस्प्लेसमेंट ही नहीं हो रहा, वो तो वहीं फिक्स्ड है, और जब डिस्प्लेसमेंट हो रहा है तो वो हवा में चला जाता है, फिर फोर्स जीरो हो जाती है। सो दैट इज अ स्टैटिक फ्रिक्शन फोर्स। ये तो समझ में आ रहा है कि वो स्लिपिंग नहीं हो रही, स्टैटिक है, और उस वर्क डन बाय द फ्रिक्शन फोर्स ऑन मी विल बी जीरो। लिखिए इसे, ये बहुत, देखिए ये वर्क डन चैप्टर में आएगा, बट आपको अभी से क्यूरियोसिटी और क्लैरिटी आ जानी चाहिए, एंड व्हेन वी आर डूइंग क्वेश्चंस थोड़ा सा क्लैरिटी हमें होनी चाहिए, दो वी आर स्टिल फोकसिंग ऑन वेक्टर। नाउ प्लीज पे अटेंशन। सो वर्क डन बाय द static friction force which is acting on my feet is zero, because when the force is acting, displacement is not happening. When the displacement is happening,
Force of light.
point of contact, point of application of force displace ही नहीं हो रहा है, तो work done by that friction force is zero. Now I have a very next level good question. This is food for thought. घर जाके खूब सोचना है, खूब गूगल, चैट जीपीटी सब लगाइए। Now ध्यान दीजिए, if I am running and मैं जीरो वेलोसिटी थी, और बाद में जब भागता रहा, एक्सेलरेट करता रहा 200 मीटर तक, तो मेरी वेलोसिटी बढ़ गई, सो माय काइनेटिक एनर्जी इंक्रीज्ड। वेयर डिड दैट एनर्जी कम फ्रॉम? किसने वर्क किया फिर मेरे पे? पोटेंशियल, ग्रेविटेशनल पोटेंशियल एनर्जी तो वर्टिकल डायरेक्शन में है, और वर्टिकली तो मैं मूव ही नहीं किया हूं, हॉरिजॉन्टली रन कर रहा हूं, तो ग्रेविटेशनल पोटेंशियल एनर्जी ने नहीं किया कुछ। वो जो मेरी काइनेटिक एनर्जी बढ़ी, मैं रन कर रहा हूं, ठीक है, जीरो थी और एक्सेलरेट होता रहा 200 मीटर तक, सो माय वेलोसिटी इंक्रीज्ड, आई एम एक्सेलरेटिंग, सो I developed gained some kinetic energy. Where did that energy come from? If no work was done by an external force, जो horizontal का friction force है, उसने तो कोई work ही नहीं किया, मैं बोल रहा हूँ. So where did that kinetic energy come from?
Chemical energy.
Not, हाँ, who's that? Muscular energy. जो मेरी body में जो muscles लग रही है ना, they did that work. और इसीलिए walk करने से energy burn होती है, walk किया करो. This was the point that I wanted to hammer. ठीक है? Now, but we learned the importance of S is the displacement of the point of application of force, and anyone who will drill this into his head properly, he will not make mistakes in work energy problems. ठीक है? So, but we are still learning vectors, so I'm not going deep into that right now. Giving you a glimpse and clearing your fundas from the roots. Now, coming back to vectors. Okay, so addition we did, subtraction you already got to know now. What you have to do for subtraction? Negative of a vector, you know, and add those two vectors. A minus B will be equal to A plus minus B, and we know how to do. Resolution we learned. Suppose we have a vector A and I want to resolve it into two mutually perpendicular directions. One is this. What will be the component of this vector in this direction? A cos theta. What will be the component of this vector in this direction? A sin theta. ये आपकी tips पे होना चाहिए. तो you can break this vector into two vectors. One vector is in this direction and the magnitude is this. Other component is in this direction and magnitude is this. And that's it. You have broken this vector into two components. If you ever break a vector into two components and you write a vector as a cos theta I cap plus a sin theta j cap, and you have broken it into two vectors, don't make a mistake of using all the three vectors. Either you use this vector or you say, okay, I've broken it into two parts and now I'll consider these two parts. Don't try to mix all the three. कि ये भी रखूंगा, ये भी रखूंगा, ये भी रखूंगा. वो नहीं करना. If I break this pen into two parts, I will have those two independent parts, right? That pen will disappear. Same is the case here. Clear? If I have added two vectors and found the resultant, then the components will disappear, resultant will work. Okay. Now, I give you a force of 100 Newton and there is a block and there is another force of 500 Newton in this direction. You will be able to find the resultant. What will be the net resultant force? 600 Newton. If I tell you there is a block, it has 100 Newton force in this direction. It has 500 Newton force in this direction. What will be the resultant force? 400 Newton towards left. I cap, J cap, you can define whichever direction. Now, if I tell you I have a force which is 100 Newton in this direction and 500 Newton in this direction, and this angle is 30 degrees, how will I find the resultant of these two forces?
It's all 500. Vertical.
There are two ways. One is triangle method, parallelogram method rather. Their tails are kept together. I can directly apply that formula. What will be the resultant force? Quickly tell me. A square plus B square plus 2AB cos theta. So resultant's magnitude will be A square plus B square plus 2AB cos theta. Am I right?
Yeah.
Root of this. Swaha. Angle which the resultant will make with vector this. This will be the resultant somewhere completing the parallelogram, right? This will be the resultant. And what will be this angle alpha? Tan alpha will be equal to quickly A mod A sin theta upon B plus mod A cos theta. Can you keep the values? Quick. 500 sin theta sin 30, which is half divided by
Plus 500.
tuck. You will know. Now there is the same question, and there is a block, and there are three forces. One force is acting in horizontal direction, 100 Newton. Another force is same, 500 Newton at an angle 30 degrees. And there is a third force acting in vertical direction, 200 Newton. There is a fourth force acting in this direction at an angle 45 degrees. Yeah, this is 100 root 2 Newton. Now, how do I add these four forces?
Polygon.
The easiest thing will be resolve these. One is polygon method, but वो तो geometrical method हो गया. आपको शिफ्ट करना पड़ेगा पैरेलल एक के हेड पे दूसरे के टेल. दैट्स मोर ऑफ अ ज्योमेट्रिकल मेथड. वो जल्दी नहीं करवाएगा अगर आपको बिना ज्योमेट्री यूज किए. क्विकली इज विल ब्रेक ऑल ऑफ देम इनटू हॉरिजॉन्टल एंड वर्टिकल कंपोनेंट्स और एनी टू म्यूचुअली परपेंडिकुलर डायरेक्शंस ले लेंगे. अब अगर मुझे हॉरिजॉन्टल वर्टिकल दिया हुआ है तो मैं हॉरिजॉन्टल वर्टिकल में ब्रेक कर लूंगा. अगर मुझे इंक्लाइन प्लेन दिया हुआ है और मोशन को उधर स्टडी करना है तो मेरी दो चॉइस क्या होंगी परपेंडिकुलर डायरेक्शंस की, पैरेलल टू प्लेन एंड. सो इट डिपेंड्स. राइट नाउ मुझे एक्स एक्सिस वाई एक्सिस दिया हुआ है एंड आई कैन सी कि इट्स वेरी इजी. एक फोर्स ऑलरेडी एक्स एक्सिस के अलोंग है, एक फोर्स वाई के अलोंग है. इन दोनों को ब्रेक कर लेता हूं. सो इस फोर्स को F1, F2, F3, F4 इन चारों को मैं IJ में लिख लेता हूँ. क्या लिखूं? F1 can be written as what?
Just
F1 is what?
100.
All of you are clear about it? F2. Quick.
No, not just. Do have to be challenged.
500 cos 30
Yes.
will be the component in this direction. So 500 cos 30 I cap. And this component 500 sin 30. Positive direction में y axis के 500 sin 30 j cap. Right. F3 force.
200.
All of you are getting there. F4. Quick. This component will be how much?
100 cos 30.
It's this component will be 100 cos 45. Am I right? This component will be 100 cos 45. 100 cos 45 in this direction. And vertical component will be in this direction. How much? 100 sin 45. Now, can you write it in I cap, J cap? 100 cos 45 is 100 by root 2. Am I right?
Yes, sir.
I cap. 100 sin 45 minus के साथ. Minus 100 sin 45 J cap. Are you getting this? Can I add all these four forces? All the vectors which are acting along I cap will get added as numbers. If they are in the same direction, they will get added. If they are in opposite direction, they will get subtracted. Same is for y direction. So let's do that. I cap, I cap, I cap. All three are positive. So the resultant force will be equal to, add all the I cap. So 100 plus
Plus 100.
cos 30 is what? 250 root 3 plus 50 cos 45 is 50 root 2. This thing into I cap. Am I right? Everyone getting it? Now let's see the J components. So this is positive, this is positive, this is negative. Am I right? Two of them are in upward direction, third component is in downward direction. These two will get added, this will get subtracted. So just add the J component. Plus
Minus 50.
what? 450.
250 plus 2.
250.
250 plus 200 or 450.
Dato mat yaar. 450 minus
Minus 50 root 2.
Minus 50.
J cap.
J cap. This is the resultant vector. I can, once I have found all this raita, I can give you 10 forces. Break them into two mutually perpendicular directions. Find the net force in X, net force in Y. And once you have found the net force in X and net force in Y, you will draw the resultant. So you got some force in X direction, right? Abhi aaya na piche? And some force in Y direction, something, Fy. And that was representing the resultant. Can you tell me what was the magnitude of resultant?
X square plus Fy square.
Yes. Pythagoras theorem, root of fx square plus fy square. We got some x component and y component, right? We got that or not? Direct face पे. Now, this is the magnitude. How do I specify the direction? Either I would have written that in IJ, IJ, जो पीछे लिखा हुआ था, वहीं छोड़ देता. That is the vector, resultant vector. If I want to write the magnitude and specify this angle by any chance, someone insists, can you tell us the magnitude? I found the magnitude also. And how do I specify this angle phi?
Fy by fx.
N phi will be equal to what?
Fy by
This is Fy, this is Fx. Tan phi will be Fi by Fx. Now, let's do a question. Easy question so that you get the hang of it. Ready? Alert. I want to see who will do it fast. There is a body. It is hanging from a string from the roof of something. There is a force acting on it. What are the forces acting on it? Tell me. So gravitational force, mg, m is the mass, and there is some tension in this string. And how do we mark the tension? Always two arrows towards each other, pointing towards each other. Always. Now, this tension, the force in the string is pulling the object upwards and pulling the roof downwards. So tension in the string, always, if I have any string and me and him are pulling that string or holding that string, either there will be a slack. We can't push each other with it, a string. The moment there will be a slack, zero force. Otherwise, tension will always be pulling him towards me and me towards him. So we always make two arrows pointing towards each other. And this gives us very clear insight that if I draw a line here, this body is being pulled with T tension upwards and T tension is pulling this wall downwards. Are you clear? So always make two arrows pointing towards each other. Now, I want to find the net force. So can the forces, both the vectors, are in the same direction or opposite direction?
I mean, like opposite.
Opposite direction. So can I write net force mg? I am assuming downward to be positive. So plus mg plus minus t. I am assuming upward to be negative. Net force is equal to what? Zero. It is in equilibrium. There's no acceleration. Net force is equal to mass into acceleration. So what is tension is equal to? We got the answer. Okay. This is how we add forces. Now, you have learned equations of motion. V is equal to u plus at. So I am giving you a question. There was a body which was moving with initially this speed, 10 meter per second along x-axis plus 20 meter per second along y-axis. This is the initial velocity of a body. There is an acceleration which is constant, and the acceleration is 20 meter per second square along x-axis only. I could have given you along y-axis also. Let me give you plus 10 meter per second square along y-axis also. Acceleration is this. Am I right with the units direction? Am I clear? Initially, the body was moving with this velocity. The acceleration was this. After 3 seconds, what will be its final velocity? V.
70 I plus 50.
So, what is the equation you will use?
A is equal to B minus
V is equal to u plus at. Or what is the definition of acceleration? Acceleration is defined as change in velocity upon time taken. This is what we say. This is always final velocity minus initial velocity. Initial velocity upon time taken. And therefore, we have initial velocity is written by u. So V final, V is equal to u plus at. Have you heard of this?
Yeah.
And we will use this vector form and find the final velocity. What will we do? Is equal to u 10 I cap plus 20 j cap u plus 80. 3 seconds. Time is 3 seconds. Multiply 60 I cap
J cap.
u plus 80 is equal to u plus 80. This will be equal to
J cap.
70 I cap plus.
J cap.
Now this is the final velocity. Are you getting it?
Yes.
What we are doing is adding vectors. V is equal to u plus 80 here, and that's it. We are learning to play with I cap, j cap. We are learning what happens when we multiply a vector by 3. Its magnitude becomes 3 times, all those things. Now, if you see, the initial horizontal velocity of a body was, say, 100 I cap. And initial vertical velocity was also 100 I cap, j cap. And then I threw this stone in such a way कि ये गया और जाके जमीन पे गिरा. ये सीखा हमने. This motion is called what? It's a two-dimensional motion. Is there any acceleration? So can I write initial velocity of the point mass to be what? What can I write? Initial velocity. 100 I cap plus. Oh yeah, this is a very debatable thing which someone just mentioned. 0.
0 to end.
नहीं एंड पे भी नहीं होगा. सुनो. सो हम ये सोचते हैं कि एक स्टोन है और मैं उसे फेंकने जा रहा हूं. तो फेंकने से पहले उसकी वेलोसिटी क्या है? आई एम होल्डिंग इट इन माय हैंड एंड देन आई थ्रो इट विद 100 रूट 2 जो भी रिजल्टेंट वेलोसिटी एट एन एंगल. सो आई ऑलरेडी टोल्ड यू 100 आई कैप प्लस 100 जे कैप. सो हैज द स्टोन लेफ्ट माय हैंड विद दैट वेलोसिटी? अरे भाई, initially it was 0. After it has left my hand, I was throwing it. After it has left my hand, it has this velocity. This is what I mean. So when you say, when I'm throwing a stone, we are not taking the moment when it is in my hand before throwing. What moment we are taking? Just after. And when it falls, hits the ground, which moment will you take? Just before hitting. And between these two events, the acceleration remained constant. What was that acceleration? Acceleration due to gravity. The earth was pulling it down always, and that acceleration was acceleration due to gravity. Between these two events. Before this moment, the acceleration was not acceleration due to gravity. I was holding it. I will give it some acceleration sudden and then throw it. After hitting, the earth will exert a instantaneous, very large force. So the acceleration, so equations of motion, there is an assumption they are applicable only when acceleration is uniform, constant. And acceleration remained constant between which 2 points? After it left my hand and before it hits the ground. All these small things will give you total clarity. Are you clear now? Now what I'm saying is, acceleration of the body is 10 meter per second square downwards. Earth is always pulling it downwards, right? So I can say minus 10 meter per second square j cap. Yes or no? This is U. This is A. I want to find it falls to the ground after some time. So where is the initial position? Where is the initial position? Here. Am I right? Where is the final position? Here. What is the displacement of the body when it falls to the ground? We do not know this distance. We call it range, R. We do not know this. It's unknown. We'll write it as R. So the displacement in horizontal direction is how much? Ri cap plus. We know the displacement in vertical direction is how much? 0 j cap. This is important information. Just see this. The particle was here. It fell to the ground. So vertical direction displacement is how much? 0. Horizontal direction, the whole displacement. This is the initial. I told you how to define displacement. Join the vector joining the initial position to the. This is the vector which represents the displacement. And it is totally in I cap, yani ke horizontal direction. What is the displacement in vertical direction? 0 j cap. Yes. And suppose I want to find time. Time I want to find. What was the total time it was in air? Which equation do you use?
Y direction.
Yes,
S is equal to ut plus half a t square. Just keep that equation. Use the values and you will get the answer. I'll tell you how. S is equal to R I cap plus 0 j cap is equal to ut 100 I cap plus 100 j cap into time we do not know, right? That is also unknown. But this equation will give you both time and range both. Just see this. S is equal to ut plus half at square, half into a, half into minus 10 into t square. No. J cap. No. Equate the I component, equate the J component. What is the I component on left side? R will be equal to, what is the I component? 100 T naught minus, sorry, that's it. That's it. I component is this only. On left, on right. This is both J component. Now, equate the two vectors to be equal there. X component has to be equal there. Y component has to be equal. So I equated the I component on both sides. And now I'll equate the J component. 0 is equal to
100 T.
100 T naught minus 5 T naught square. From this quadratic equation, I'll get the value of T naught. So total time of flight. So आप देख रहे हैं, we are now doing projectile motion. वो चैप्टर में यही हो रहा है. इधर अपन वेक्टर्स की प्रैक्टिस कर रहे थे कि चलो थोड़ा वेक्टर्स से प्ले करते हैं, v इज इक्वल टू u प्लस at करके देखते हैं. उधर अपना प्रोजेक्टाइल मोशन चैप्टर समझ में आ गया आपने. रेल बनाना चाहता हूं मैं आप लोगों की, इतनी स्पीड से दौड़ना है हमें. थोड़ा आइडिया हो रहा है ना. अब घर जाके जब प्रोजेक्टाइल मोशन देखोगे सब समझ में आएगा. अरे ऐसे रिजॉल्व कर लिया इनिशियल वेलोसिटी और यही हो रहा है और पूरा चैप्टर इस पे है. कई महीने पढ़ाते रहते हैं प्रोजेक्टाइल मोशन. Are you getting the hang? Now, so from here, quadratic equation, 5 common, T naught common. So either T is 0, it's a quadratic equation. T common आ गया. Two things multiplied. One is 100 minus 5 T naught. Other is T naught. And they are equal to 0. So either this is 0 or this is 0. So T naught is equal to 0. One solution. Yes, it was having vertical displacement 0 when time was 0. Yes. Again, it had vertical displacement 0 when time was 20 seconds. So your time of flight was, it was in air for 20 seconds. What is the range of the projectile? 20 into 100, 2000 meters. You learned projectile motion and there was nothing to learn in it. You just decided a two-dimensional motion will be represented by I cap, J cap. So if a three-dimensional motion is happening, just see, it is so difficult for you to visualize. For example, this is x-axis, this is y-axis, and this is z-axis. Okay? And this is a point here. And I am going to throw it in this direction. And it will go and fall somewhere. Now, all you have to do is, you have to specify the initial point, where it is located. That will be the position vector of that point in space. X coordinate, Y coordinate, Z coordinate. And then you specify the velocity in I, J, K cap. Bhai, what is the component along x-axis? What is the component along y-axis? What is the component along z-axis of the velocity? Initial. And you use v is equal to u plus at, s is equal to ut plus half at square. Acceleration also you will write in terms of I, j, k. V will also be in terms of I, j, k. And in 3D, which is so difficult to even visualize how it is moving, x direction make it, and in vector form, it becomes like so easy to deal with I, j, k components. So please understand, vectors represented in terms of I, j, k gives you a very powerful tool of understanding and visualizing motion or equations in easy terms. Are you getting some feeling of what power vectors has when you represent them? Okay. Now, so coming back, I do not want to do full mechanics today. What I want is giving you a glimpse. We want to deal with vectors. There is one way that I can keep in a dull way, keep talking about A vector, B vector. The other way was I had an option of, now we are coming to addition, subtraction, we did the theory part. Now let's do quickly the dot product and cross product also. And then we'll be doing questions after that. So understanding that, those two parts today itself, A vector. So we learned addition, subtraction, multiplication of a vector by a number. Suppose n is a number. What does it do to it? If it is a normal number, it's not a vector. What happens to the vector? Its magnitude becomes n times a. So its magnitude becomes n times a. Will there be any change in its direction? The direction remains the same. So multiplied by a unit vector along a direction. Multiply by a unit. दे दीजिए जिसको. Now, so when I multiply a vector by a scalar or a number, its magnitude becomes this much. If I multiply it by -1, what is happening? Direction becomes opposite, magnitude remains the same. If I multiply it by 3, 3 times, direction remains same. -3, सब clear है? Good. So multiplication of a vector with a number is easy. If I multiply it by half, magnitude is half, direction remains same. Now, if I multiply a vector by another vector, there are two mechanisms. One is dot product, other is cross product. In nature, when we study vector quantities, vectors, this is defined because when we say work done by a force, so we said F dot S. Now, work done by a force is in this form, so we are defining how to do a dot product between vectors. Okay. Cross product is also being defined because in many such cases, when electromagnetic waves are propagating, so electric field and magnetic field, changing electric field produces magnetic field, changing magnetic field produces electric field, and those electromagnetic radiations, when they are moving, they have E component and B component. ये सब आप आगे के chapters में करेंगे. Right now, just keep hearing the vector part of it. बाकी सब bouncer जा रहा हो चलेगा. So ये जो दो चीजें हम define कर रहे हैं ना, they are being done, defined this way because they will be needed when we will be studying physical phenomenon. We will be studying physics and vectors and nature. At that time, we will need these operations of vectors. So they are being defined, abhi se. Are you getting it? So dot product is what? Magnitude of A, magnitude of B, cos theta. And is it a vector or a scalar? Scalar. There is no direction. And this is the magnitude, this is the magnitude, this is the angle between the two vectors. Clear? A dot B. So easy. Nothing much to be done in it. Now, what is A cross B? Magnitude of A, magnitude of B, sine theta. And this is going to be a third vector. And that vector will have a direction, and let's call that direction to be n cap. And we'll understand what is that direction. These are the two operations that you need to understand. How a vector multiplies with another vector. One multiplication is dot product, one product is dot product, other product is cross product, which is called vector product. So this will give you a third vector, some vector C. And that direction and magnitude you should know. Magnitude is very easy. ये तो दोनों की समझ में आ गई. Given theta, you can easily find that. Direction और समझ लेता है. So A dot B is magnitude of A, magnitude of B, cos theta, where theta is the angle between the two vectors, and I have told you how to define the angle between the two vectors. A cross B will be magnitude of A, magnitude B, sin theta, where theta is the angle between two vectors. This is the magnitude. Direction I'll just specify. If you have a vector A, you have another vector B. This is vector B. So the first thing when you want to find cross product, shift the two vectors and put their tails together. Because that's important for us to find the angle also. And that's also important for us to find the direction of A cross B. So what do I do? क्या करूं? B को shift करते हैं और उसको वहीं पे ले आते हैं. दोनों की tails को एक जगह रखते हैं. ये मैंने यहां से shift किया और मैं B पे ले आया. Inertia. A and B. I want to do A cross B. First tell me what is the angle between these two vectors. Quick. कौन सा एंगल है वो? स्मॉलर एंगल. ये तो पता लग गया. Now hold A and turn it towards B through smaller angle. Hold a screw, right hand screw rule. Curl of your fingers A towards B. तो screw thumb किधर जाएगा? Into the plane. So A cross B direction will be into the plane. If I tell you find B cross A, you will hold A, turn it towards B through smaller angle, not this angle. Be clear about it. Through smaller angle. So B cross A, the direction will be outwards. So if I ask you, what is the direction of A cross B? Into the plane को आप ऐसे बना देंगे. And if I tell you A cross B will be, N cap will be into the plane. है ना? Direction. And B cross A? You got it? Have you understood the direction part? No, we'll come to it. फिर से आएंगे. अब, quick. If I have a vector 10 I cap plus 20 j cap, this is vector A. And there is another vector B, which is 5 I cap plus 4 j cap. I want to find the dot product. Can I say A dot B will be equal to this dot this? Am I right? Now, vector dot product is distributive. ये सब पढ़ा है distributive. ये क्या होता है? 2 into 3 plus 5, suppose. So this is same as 2 into 3 plus 2 into 5. So this is a distributive. Multiplication is distributive. Same way, dot product is also distributive. A plus B is B plus A. What is that called? Commutative. So ये सब properties थोड़ी सी commutative, distributive, they are applicable here. And now, coming back to, so if I do that, I will have A dot B. What will be A dot B? Who will tell me? A dot B can be written as, one way is I can find the magnitude of A, magnitude of B, but I don't know the angle between them right now. Am I right? अगर एंगल पता होता, कोई मुझे बोल दे there is a vector which has magnitude 100 Newton, another vector B magnitude, another vector B which has magnitude 200 Newton, and the angle between them is say 60 degrees. Can you find A dot B? Very easily. What will be A dot B? Magnitude of A, magnitude of B, cos 60. So simple. But here, if I tell you find A dot B, you don't know the angle. So you cannot use that direct formula. But let's do A dot B because distributive hai. A dot B will be this dot this plus this dot this plus this dot this plus this dot this. ये तो पता है? Now let's do that. 10 I cap dot 5 I cap plus 10 I cap dot 4 J cap plus 20 J cap dot yes, and next 20 J cap, correct. Now can anyone tell me what is I cap dot I cap? 10 into 5 is 50. Numbers तो आ जाएंगे अलग. We will have I dot I. What is I dot I? I की magnitude is 1, I की magnitude is 1, and what is the angle between the two vectors?
0.
Cos 0 is
1.
so this value will come out to be,
1.
will it be a vector?
Oh.
So it will be 50 only. Plus, what is I dot J?
40 into 0 was 90.
1 into 1 magnitude into cos 90. I and J are mutually perpendicular. One is along x-axis, one is along y-axis. So what is the angle between I and J? 90 degree. Sin cos 90 is 0. So this term will become I dot J will be 0. Same way J dot I will be.
0.
What is J dot J?
1.
So final term is, what is the net answer? So without knowing the angle, you were able to calculate dot product. Now let me generalize it for you. Okay. If I have a vector A1 I cap plus A2 J cap, B is B1 I cap plus B2 J cap. You will do the same thing. And finally, you will get the result. A dot B will be equal to A1 B1. Simple. Can you see this? What will happen to I dot I?
1.
What will be I dot J?
0.
You are getting all that? How we got this result? If I had a vector in 3D, A3 J cap, B3 K cap, sorry. So what will be A dot B? Simple. सब I dot J, I dot K, वो सब क्या हो जाएंगे? Mutually perpendicular वाले cos 90 is 0. You will get this result. Remember this. If A vector is this, general vector, B vector is this, A dot B will be this. Without even knowing the angle. If he would have told me, now in the same question, if I tell you find, देखिएगा. If in the same thing, same, what is the question? This is the question. A is this. A is this. This is a general vector. This is B, a general vector. Okay? I can find A dot B. What is the magnitude of A? Quick. Root of this square plus root of this plus this square plus this square. You know this? We found. So root of a1 square plus a2 square plus a3 square. What is magnitude of b?
B1 square plus B2 square plus B6 square.
So if I know the magnitudes, can I write a dot b as magnitude of a, magnitude of b cos theta? Yes or no?
Yes.
Yeah.
Where theta is the angle between the two vectors. In this case, I don't know the angle between the two vectors. I have vectors in IJK form in 3D. I want to find that angle. I can find it now. The angle between the two vectors will be theta, where cos theta is this. I know this, I know this, I know this. So A dot B, which is A1 B1 plus A2 B2 plus A3 B3 divided by magnitude of A, which is this, right? Divided by magnitude of B. And this will be equal to cos theta. And you will be able to get theta angle between the two vectors. So now you do this question. I am telling you there is a force which is 10 Newton I cap minus 20 Newton J cap plus 5 Newton K cap 3D में कितना difficult लग रहा है? This is a force. And this is a vector F1. And there is another force vector, which is 2 Newton I cap plus 1 Newton J cap plus 4 Newton K cap. Find me the angle between these two forces जो 3D में है. देखिए विजुअलाइज करना कितना मुश्किल है. एक कुछ ऐसे है फोर्स 3D में और एक कुछ ऐसे है स्पेस में 3D में. You have to find the angle between them. कितना डिफिकल्ट है इमेजिन करना विजुअली. But mathematics, systematic, structured approach will give you that answer clinically, and you will be precisely able to tell cos theta will be this much, theta will be cos inverse of this much. That easy. That's systematic. Now, what will you do? Quick. What you will do is F1 dot F2. You can find out what will that be. A1 B1 है ना 20 minus 20 plus 20. Am I right or not? F1 dot F2 is this A1 B1 plus A2 B2 plus A3 B3. This is equal to 20. So easy. F1 dot F2. Now, there is another way of finding F1 dot F2. What is that? This is also equal to magnitude of F1 plus magnitude of F2 cos theta, where theta is the angle between them, which I have to find out. Can I find the magnitude of F1? Root of this square plus this square plus this square is magnitude of F1. What is magnitude of F2? Root of this square plus this square plus this square. Are you clear? How many of you are able to absorb, understand till here? सबको समझ में आ रहा है?
Yes.
कुछ डिफिकल्ट लग रहा है? थोड़ा ज्यादा फास्ट जा रहा हूँ?
No.
कितने बजे तक थी क्लास?
10:30.
ठीक है, अब पागल हो जाओगे उसके बाद. हाँ.
So why is F1 equal to under root b square plus?
Yes, that's a good question. ये मुझे भी रियलाइज हो रहा था, मैं शायद वो बताया नहीं है. चलिए कर देता हूँ. So how can you say magnitude is this? So if I say there is a vector which is अभी x और y axis ले लेते हैं. There is a vector which is fx, component is fx, and this is y component. And I tell you, find the resultant magnitude of this. So magnitude of this will be this. Am I right? Resultant. And this is suppose x-axis and this is suppose y-axis. So I am also writing that this force is fx I cap plus fy j cap. यही है ना force? This is. Now, can you use Pythagoras theorem for this? This is fx, this is fy. what will be the resultant magnitude? Root of and if you will have three components, the third component will be, so this I found R1 बोल देता हूं इसे मैं. This is say R1. Now if I had three forces, so there was a third dimension also. The third dimension was along z-axis. This is z-axis. So I first added fx, fy. I got this R1. R1. Now there is a third dimension which is fz. The third component is, suppose this was fz k cap. Now I will add this vector, R1 vector, and this vector, fz. What will be the magnitude? Root of this square plus this square. So root कर लेता है. So resultant magnitude will be equal to root of fz square plus magnitude of this square, which will be fx square plus fy square. And therefore, you get the resultant of all the three vectors will be this. So when I say if there is a vector a1 I cap plus a2 j cap plus a3 k cap, the resultant of the magnitude of that vector will be root of a1 square plus a2 square plus a3 square. So sorry I skipped that and good you reminded me. Good. That was a valid question. Everyone clear? I am in full length. Full length मतलब full जोश में हूं. तो मेरे लिए भी और आपके लिए भी. I do understand कि मैं तो थोड़ा सा फिजिक्स को 25 साल पढ़ता ही रहा हूं और आप लोग पहली बार 11th में आए. तो I will give you that breathing time, that space, that comfort. You develop first the confidence. But can you understand what I'm teaching? Is this making sense, logic, and it is not like I'm going bouncer to you? वो clear है? ऐसा तो नहीं फील हो रहा. अगर बाई चांस किसी बच्चे को ऐसा लगे कि मेरी थोड़ी ये आदत है, मेंटल प्रॉब्लम है कि मैं थोड़ा ना फास्ट चलता हूं, मुझे ये लगता है कि इकोनोमाइज करते हैं एक एक चीज को, फास्टेस्ट रूट पकड़ता है, तो मैं थोड़ा सा ज्यादा ही फास्ट चलता हूं. सो अगर बाई चांस ऐसे लगे तो एक दूसरा भी बैच है, उसमें मैं थोड़ा और स्लो पढ़ा दूंगा. एक बाद में कोई बैच शुरू होगा या कोई और टीचर पढ़ाएगा, उसमें अटेंड कर लेना. या जैसे अभी दूसरे सेंटर पे कहीं लेक्चर हो रहा है तो वो लेक्चर भी रिकॉर्ड हो रहा होगा, तो आप उस टीचर का लेक्चर ले लेना. तो वो थोड़ा सा यू विल नो कि भाई अगर त्यागी रॉकेट बनाए हुए है तो दूसरा अगर प्लेन में चला रहा है तो प्लेन में चल लेते हैं. तो कभी ऐसी कोई प्रॉब्लम आए, you will have options, you will have solutions in place. ठीक है? So don't get demoralized. अगर त्यागी सर का लेक्चर कुछ टफ जल्दी जल्दी पढ़ा दिया, भाई थोड़ा सा जोश है मेरे अंदर भी, बट आई डू अंडरस्टैंड पहली क्लास है, पहला लेक्चर है. डोंट गेट डिमोरलाइज्ड, जस्ट बी कॉन्फिडेंट. धीरे धीरे यू विल गेट द हैंग ऑफ इट. थोड़ा सा सिंसियर रहना, घर जाके थोड़ा रिवाइज, पढ़ना, बुकलेट को पढ़ना, अच्छे से क्वेश्चंस करना, एक्सरसाइजेस गिवन बिहाइंड. When you come for the next lecture, next week, एक वीक मिल रहा है आपको, उस एक वीक में आपको बुकलेट से जरूर पढ़ लेना है. कुछ चीज थ्योरी या एक्सप्लेनेशन पढ़नी है तो रेसनिक हेलिडे एंड एनसीईआरटी थ्योरी के लिए. बुकलेट से थ्योरी इज कंडेंस्ड, की चीजें दी हुई हैं, डिटेल्ड एक्सप्लेनेशन नहीं होता है, वरना तो वो बहुत मोटी बुक बन जाएगी. बुकलेट्स आर फॉर डूइंग गुड प्रॉब्लम्स. क्वेश्चंस विल बी रियली गुड. Are you getting it? Theory, रेसनिक, जब भी कोई कॉन्सेप्ट समझना हो ना इंट्रिकेट, ये तो अभी बहुत बच्चों वाले इजी, जब अच्छी चीजें रोटेशन और सेंटर ऑफ मास और बाकी चीजें आएंगी तो उसकी थ्योरी को आपको रेसनिक से या एनसीईआरटी से. इज दैट क्लियर? चलिए, ऑल द बेस्ट.